Your eyes fix on a shotgun that you're holding in your hand.
Prepare their minions for the tasks ahead. After several days, the lair of the Dwarven King Sturmir had been found by scouts of the undead. He sheltered himself in his impregnable mountain fortress, south of Ethral's mines. Mortis was almost avenged, and her undead hordes ventured to accomplish the nearly impossible task of destroying the mountain clan's century-old monarch in his fortified keep.
To me, death to the living. Leave that to me. Death to the living. to me.
Опять же, по многочисленным просьбам мы продолжаем цикл о морских сражениях, и сегодня будет разговор про Трафальгар.
Да, Трафальгарское сражение – это, может быть, самое известное сражение в мировой морской истории. И я не буду сразу говорить, что я представлю какую-то революционную версию Трафальгарского сражения, что англичане проиграли, там Нельсон не был великим полководцем, или это был результат мирового заговора, что должны были выиграть французы, но вот Ротшильд там решил, что это будут англичане. Нет, безусловно, Трафальгарское сражение – это крупнейшее, важнейшее сражение, одна из славных побед английского флота. Но интересно было бы посмотреть на общую ситуацию и на детали. То есть поставить в правильный контекст сражения и посмотреть на те факторы, в результате которых англичане оказались победителями. Ну и посмотреть, дорого ли им эта победа досталась.
Ну, я вот всегда всех прошу, когда мы говорим о военной истории, рассказать про политический контекст.
Да, с этого надо начинать. Значит, начнем с того, что революционные войны начались еще в 90-е годы XVIII века, но они формально закончились в начале 1802 года, когда Англия и Франция заключили, наконец-то, Амьенский мир. Ну, до этого еще в 1801 году заключила мир с Францией и Россия. В общем, распалась очередная антифранцузская коалиция. Ну и, казалось бы, заключение англо-французского мира через 9 лет войны в феврале 1802 года должно было означать более-менее длительный период. Но я напомню, что до этого между войной за независимость Соединенных Штатов и революционными войнами прошло свыше 10 лет. То есть, ну, в общем, наверное, можно было ожидать какого-то более-менее длительного периода мира. Но этот период не наступил. Через год с небольшим, в мае 1803 года, война возобновилась, как англо-французская война. И поначалу она ведется только между Англией и Францией. Причем этой войны желали обе стороны, и они с удовольствием ее возобновили. При этом Наполеон, как гениальный полководец, понимал, что нужно врага бить по голове, нужно наносить удар, так сказать, в самое сердце. И, естественно, он начинает готовить десант на Британские острова. Эта мысль была отнюдь не новой. То есть, даже на памяти людей, которые были современниками Булонского лагеря императора под городом Булонью на берегу Ла-Манша, собиралась эта огромная армия. Современники еще помнили Армаду 1779 года. Это попытка высадки во время войны за независимость Соединенных Штатов. До этого была попытка в 1759 году. И попытка наполеоновская, она даже по масштабам не очень сильно превосходила, скажем, приготовление 59 или 79 года. Наполеон собрал 130 тысяч человек и от 2 до 3 тысяч судов для переправы этой армии. В принципе, подобные же масштабы подготовки были и в 79 и в 59 годах.
Вот это уникальная история, что было несколько замыслов десанта на Британские острова, и ни один в итоге не реализовался.
Да, но видите, на самом деле, вот когда говорят, что только Вильгельму Завоевателю в 1066 году это удалось, это неправда. Успешный десант в Англию совершил Вильгельм III в 1689 году, во время славной революции. И именно эти события были образцом для последующих попыток вот этих десантов XVIII века, потому что дореволюционная Франция собиралась опираться еще и на якобитский заговор. Но вот Наполеон уже мог опереться разве что только на восстание в Ирландии, и он предполагал высадить часть войск в Ирландии, а главные силы в Южной Англии. Но, в принципе, по той же схеме действовали и предыдущие французские планировщики этой операции. И Британия оказалась 1 на 1 с этой угрозой. Это была неожиданная для англичан история. С континентальных союзников у них в 1803-1804 годах не было. И Британия лихорадочно начинает поиск союзников. Этот поиск завершился успехом, потому что летом 1805 года к Англии примкнула Австрия и Россия. Ну, здесь можно долго очень обсуждать, насколько это все было нужно России и зачем вообще Россия влезла.
Но Англии это было нужно очень.
Англии это было нужно обязательно. И я бы хотел подчеркнуть важнейший момент. Когда говорят, что Трафальгар спас Великобританию от вторжения французских войск, это не так. Трафальгар состоялся в октябре месяце, а Наполеон отказался от вторжения в Англию в августе 1805 года, потому что Австрия объявляет ему войну, и австрийские войска вторгаются в Баварию, и русская армия во главе с Кутузовым идет на помощь австрийцам. И Наполеон переименовывает армию океана, как она называлась до этого, и в Булонском лагере сосредотачивалась в Великую армию, Гран Арме, простите за мой французский, и после этого идет на Австрию, ну и дальше будут капитуляция Макка при Ульме, ну и в конце концов Аустерлиц в конце этой кампании. А Трафальгар был следствием не попытки французов сосредоточить флот для броска в Англию, а как раз следствием отказа этой попытки. Но давайте перейдем к деталям. К моменту тут уместно первую картинку показать, карту. На карте, которую вы сейчас видите, представлена дислокация французского и английского флота и сухопутных войск. Сухопутные войска показаны квадратиками, флот такими округлыми фигурами. И вы можете видеть, что французский флот, как всегда, был разделен. Одним из проклятий французского флота было деление его на Атлантический и Средиземноморский. Атлантический флот в Бресте, Средиземноморский в Тулоне. Но это, в общем-то, в нашей стране еще более ярко проявляется, деление на разрозненные морские театры. Но вот французы тоже были разорваны. Кроме того, Испания, которая примкнула к Франции в этот момент, она держала свой флот в Кадисе. Кроме того, часть кораблей находилась в Эль-Ферроле, это еще одна испанская база на берегу Бискайского залива, и небольшой французский отряд в Рашфоре, как бы на другом берегу Бискайского залива. Против каждого из этих портов находилась английская эскадра, которая блокировала французские и испанские корабли. Причем английские эскадры в каждом случае были несколько меньше, чем блокируемые ими силы. Но и вот здесь я бы подчеркнул очень важное обстоятельство. В парусном флоте техника не играла той определяющей роли, которую она играет в 20 веке. Да и то в 20 веке надо подчеркнуть, что, знаете, известный парадокс, когда у немцев были плохие танки, а у нас хорошие, мы отступали до Москвы, а когда у немцев появились хорошие танки, а у нас танки стали не такими хорошими по сравнению с немецкими, мы наступали до Берлина. Поэтому голое техническое какое-то, какие-то кунштюки технические в голом виде, они не способны повлиять на ход боевых действий. В конечном счете воюют люди, а не железо. И если в 20 веке роль техники она несколько выше, то в начале 19 века роль техники была более скромной. И, скажем, никакие изобретения, там, какие-то локальные попытки улучшить те или иные элементы оснастки кораблей там, или пушки, они не могли сыграть решающую роль. Более того, французские, испанские корабли часто были построены более качественно, чем английские. Они были построены не только из лучшего леса, особенно испанские, кстати, корабли отличались очень высоким уровнем инженерным. Они были часто просто больше и лучше вооружены. Можно вспомнить, что в Трафальгаре участвует уникальный испанский корабль «Сантиссимо Тринидад», единственный четырехдечный линейный корабль в то время, потому что, как правило, на линейных кораблях пушки находились либо на 2, либо на 3 закрытых палубах и еще на одной открытой палубе. А на Сантиссиме Тринидад они находились, получается, на 5 ярусах, 4 закрытых и 1 открытый. 136-пушечный корабль, один из крупнейших парусных кораблей вообще в мировой истории. Ничего подобного у англичан не было. Англичан, тоже были неплохие корабли, но это были не шедевры. Но, тем не менее, побеждают англичане. Более того, можно еще один парадокс подкинуть. Теоретическая подготовка французских и испанских офицеров стояла гораздо выше, чем английских. Потому что и во Франции, и в Испании была отработанная система военно-морских учебных заведений. Это гардемаринские роты с 3-летним сроком обучения. Они назывались ротами, но фактически это были учебные заведения, где будущие моряки получали солидную теоретическую подготовку, и только после этого они проходили практику на кораблях. В Англии юный джентльмен, young gentleman, так и назывался, уходил в море в 12 лет или в 11, как Нельсон. и служил чему-то там теоретически, обучался, потом сдавал экзамены, становился офицером. То есть теоретическая подготовка английских офицеров была хуже. И тем не менее, то есть и корабли вроде бы хуже, и офицеры хуже, а побеждают все время англичане.
А Англия владычица морей.
Англия владычица морей, да. Почему? Ну, прежде всего, именно потому, что для Англии флот имел первостепенное значение. И флот находился в фокусе общественного внимания для начала. А кроме того, если Англия впадала в какой-то финансовый кризис, то она начинала экономить не на флоте, а на всем остальном. С другой стороны, любой противник Англии, будь то Франция в XVIII веке, будь то Германия в XX веке, Россия в XIX веке, в конце концов, они вынуждены были делать ставку на сухопутную армию. Потому что враг пешком до Парижа, или до Берлина, или до Москвы, или до Петербурга дойти мог. А флот не мог. Соответственно, и когда Франция оказывалась, или Германия, или Россия в кризисном положении, то расходы на флот резко сокращались. И поэтому история любого флота, любой континентальной державы выглядит как кардиограмма сильно больного человека. Там то взлеты, то падение. А в Англии она такая более-менее ровненькая. Это было крайне важно. И второе обстоятельство заключается в том, что английский флот приобрел привычку к господству на море, если так можно выразиться. В силу ряда обстоятельств, это еще заложено было в XVIII веке, англичане привыкли к тому, что они блокируют французские и испанские порты, а французы и испанцы привыкли к тому, что они отстаиваются в этих портах, будучи заперты английской блокадой. И в этой ситуации каждый день, проведенный в море английскими моряками, добавлял им навыков. Надо сказать, что английские матросы, например, они были не лучше французских, в том смысле, что когда, или испанских, в том смысле, что когда разворачивался флот из 100 линейных кораблей, а такое бывало в 18 начале 19 века, англичанам приходилось загребать на флот кого угодно. И кроме профессиональных моряков из торгового флота, попадала куча людей, которых называли landmen, то есть необученный абсолютно человек, которых хватали где угодно, которых суды приговаривали к службе на флоте. Там могли быть шахтеры, пастухи, крестьяне, кто угодно. Но их могло быть треть, скажем, экипажа. Но несколько месяцев в море, и эти люди начинали вполне удовлетворительно выполнять обязанности матросов. Ну а через 2-3 года они могли стать им уже высококвалифицированными матросами. Когда же подобная ситуация случалась во Франции или в Испании, то у этих новобранцев просто не хватало морской практики для приобретения нужных навыков. И хотя в порте, казалось бы, стоять было комфортнее, и, казалось бы, можно было там, гонять матросов по вантам, что называется, но и чинить повреждения, но это все не приносило реального морского опыта ни офицерам, ни матросам. И вот эта вот привычка находиться все время в море, привычка побеждать была очень важным фактором для британского флота. И, собственно, Трафальгар покажет, что англичане старались сойтись не то что на пистолетный выстрел, а свалиться на абордаж с кораблями противника, будучи одушевлены, так сказать, сознанием собственной непобедимости. Это очень сильный фактор, такой моральный, который действительно способен принести много пользы, когда эта уверенность в своих силах подкреплена еще и большим опытом. Ну и, в общем, мы увидим, забегая вперед, скажу, что в Трафальгарском сражении Нельсон не проявил каких-то там выдающихся качеств тактика, он не совершал никаких сложных, там, многомудрых маневров. Он просто атаковал французскую и испанскую эскадру и добился побед.
Друзья, регулярно встречаться с цифровой историей можно не только в сети, но и на экскурсиях. На пешеходных и теплоходных лекциях в Санкт-Петербурге я, Егор Яковлев, расскажу вам немало увлекательных исторических сюжетов прямо на местах событий и с удовольствием отвечу на
старается
актуальное
Наполеон
в описании.
Но Наполеон, пока еще шло лето 1805 года, пока еще Австрия не вступила в войну, Наполеон старается успеть вторгнуться в Англию, понимая, что, в общем, постепенно формируется континентальная коалиция. И он в значительной степени, ну, как бы сказать, дал верные советы своим адмиралам. Но он не был моряком профессиональным, но хорошо, так сказать, представляя себе стратегию, он мог правильно оценивать ситуацию. Он создал план сосредоточения французского флота в Ла-Манше для прикрытия десантной операции. Понятно, что можно было дождаться безветрия и попытаться на удачу провести 130-тысячную армию в Англию. Но Наполеон, будучи реалистом, понимал, что поднявшийся ветер приведет к чудовищной мясорубке в Ла-Манше, если английский флот вдруг в ней появится. Но не говоря уже о том, что армия будет отрезана английским флотом от любой связи с Францией. И даже в условиях 19 века, когда снабжение боеприпасами, скажем, было не столь громоздким, как в 20-м, а продовольствоваться можно было за счет местности, в которой армия находилась, все равно это было неприятным моментом. И все равно могла сложиться ситуация, когда Наполеон Лондон возьмет, но от Франции будет отрезан. Ну, это, конечно, история достаточно дурная. Поэтому Наполеон хотел сосредоточить весь французский и испанский флот в Ла-Манше, с тем, чтобы он, ну, пускай и не очень успешно действовал против английского флота, и сковал бы его. А под прикрытием своего флота уже перебросить войска в Англию. И план этот был таким глобальным. План сосредоточения французского флота предполагалось, что французские эскадры будут отправиться сначала в Карибское море из Средиземного, а затем они соединятся и затем вернутся обратно в Европу. А англичане будут за ними гоняться. Тут еще надо понимать, что при отсутствии радио и при отсутствии телеграфа информация проходила медленно. И, скажем, управление флотами, разбросанными на просторах Мирового океана, было крайне затруднено. То есть, собственно, командующие могли только гадать, что происходит, не могли обеспечить между собой связи. Тоже судно, посланное с сообщением, могло быть перехвачено, могло быть задержано ветрами, могло просто, так сказать, погибнуть из-за навигационных каких-то происшествий. И информация эта вообще могла никуда не прийти, а могла запоздать очень надолго. То есть, в общем, ситуация была сложная. Сложнее, чем на суше, надо сказать. Знаний о местоположении вражеского флота у адмирала 18-го, начала 19 века было меньше, чем у генерала, командующего сухопутной армией. Ну и французы действительно сходили в Карибское море, потом вернулись. Нельсон, который преследовал средиземноморскую французскую эскадру, совершил несколько, в общем-то, ошибок. Но, кстати, надо сказать, это малоизвестный факт, что Суворов Александр Васильевич успел покритиковать адмирала Нельсона в одном из своих писем. И Суворов заметил правильную очень вещь, что Нельсон очень разбрасывается. И он, как бы сказать, не пренебрегает возможностями бить вражеский флот сосредоточенно. Но, может быть, Суворов уловил здесь определенный недостаток Нельсона как стратега. И Нельсон имел предвзятую идею, что французы готовят высадку в Египте новую. А Наполеон сознательно пытался их в этом убедить. Он сосредоточил один из корпусов своей армии на южном побережье Италии и намекал всячески, что он собирается снова в Египет. А англичане как-то по этому поводу очень нервничали. И Нельсон, преследуя эскадру Вильнёва, которая вышла из Тулона, сначала сходил в Египет, обнаружил, что там никого нет. Потом сходил в Карибское море, обнаружил, что Вильнёв там был, но уже уплыл. Снова вернулся в Европу. В общем, потеряно было довольно много времени. Но, с другой стороны, все-таки по морю корабли передвигались довольно быстро. И за сутки парусные корабли проходили несколько сот километров. Это позволяло перемещаться через Атлантику в течение недель, скажем, а не месяцев. Поэтому за лето 1805 года и французы, и англичане успели побыть везде. Значит, но в результате этих передвижений положение французов улучшилось. Потому что вместо того, что они были разорваны на 4 части, ну плюс еще Рашфордский отряд, теперь они оказались разделены на 2 главные группировки. Я испанцев с французами вместе считаю. На 2 главные группировки, одна из которых была в Бресте, а другая была в Эль-Ферроле, на побережье Бискайского залива, принадлежавшем Испании. И Далее Наполеон пытается последнюю попытку осуществить сосредоточение флота в Ла-Манше. И в начале августа он отдает приказ Вильнёву идти в Брест из Эль-Ферроля с тем, чтобы разгромить английскую эскадру, которая блокирует Брест, и соединиться в Бресте с остальными французскими кораблями. В общей сложности это должно было дать 50 испанских и французских линейных кораблей в Бресте. Это огромная сила. Ну, а англичан в это время напротив Бреста было где-то около 35 линейных кораблей. То есть полуторное превосходство. В принципе, это могло дать победу французам. Но вообще Наполеон всячески негодовал по поводу того, что французские адмиралы пассивны. И он даже написал как-то в одном из писем: «Я хочу найти 2-3 адмиралов, которые по-настоящему желают умереть, для того, чтобы поставить их во главе моего флота». И он говорил, что ему не нужна победа, ему нужно ослабление английского флота. То есть флот даже может пожертвовать собой французский, но он окупит эту жертву тем, что сухопутная армия окажется в Англии. Наполеон в этом плане мыслил вполне логично, он правильно расставлял приоритеты, но адмиралы... Опять же, французские адмиралы привыкли к осторожности, я бы так сказал.
Умереть никто не хотел.
Ну, не особенно, да. Вот это такая интересная история, потому что, хотя вроде бы как они были не очень пожилыми людьми, и мы сейчас пару слов, надо сказать, наверное, и об адмиралах. Давайте посмотрим на этих людей, которые тут у нас сегодня на сцене.
Вообще, такая ремарка: странная позиция для морского офицера. Ведь это победить англичан, это сразу вписать себя в историю.
Ну, даже геройски, как бы сказать, погибнуть в бою с англичанами.
Да.
Вот. Но чего-то вот не хватало, чего-то не доставало. Это сложный такой вопрос.
Они просмотрели этот исторический шанс.
Как это, так сказать. Но, знаете, это просто история имела свою, как бы сказать, длинный хвост истории. Это имела. Это некоторая робость по отношению к англичанам. Она отличала французов и в Семилетнюю войну, и во время войны за независимость Соединенных Штатов.
Нашему национальному характеру это непонятно.
Ну, видите, тут тоже есть на самом деле, вот если так строго рассуждать, были ситуации, когда она отличала длинный хвост. Но, знаете, это просто история имела свою, как бы сказать, длинный хвост истории. Это имела. И это некоторая робость по отношению к англичанам. Она отличала французов и в Семилетнюю войну, и во время войны за независимость Соединенных Штатов.
Нашему национальному характеру это непонятно.
Ну, видите, тут тоже есть на самом деле, вот если так строго рассуждать, были ситуации, когда наши адмиралы робили англичан, и можно вспомнить это, в общем, один из самых позорных эпизодов в истории нашего флота в 1809 году, когда 2 английских корабля уничтожили русский корабль «Всеволод» на глазах русской эскадры адмирала Ханыкова. Но, правда, Ханыков за это был разжалован в матросы на сутки и выкинут со службы. Ну, вот, то есть у нас тоже бывали такие вещи, но я не готов просто здесь строго судить французов. Это вопрос сложный и такой аккуратный. Но посмотрим на людей самих. Ну, понятно, что в центре сам Нельсон, тут его портреты можно увидеть. Все привыкли к тому, что он однорукий и одноглазый. Но когда-то он был молодой, с обеими руками и 2 глазами. Типичный английский морской офицер. Родился в 1758 году, был одним из младших сыновей священника. Ну, в Англии, кстати, священники занимали, да, как и в России, впрочем, невысокую социальную ступень. И он еще был болезненный. В 11 лет он поступил на флот. Ну, говорят, юнгой, но это не совсем правильно. В Англии было 2 категории юнг. Были бой, это мальчик из простых, который будет матросом. А young gentleman – это мальчик из непростых, который будет офицером. И поэтому считать, что Нельсон был простым юнгой, некорректно. Но он уже в 20 лет стал капитаном. Но, правда, в английском флоте не было рангов, на которые мы привыкли, там, 1, 2, 3 ранга капитана. То есть он уже получил под командование корабль. И в его копилке было несколько сражений. Была победа над французами при Абукире громкая. Был бой с датчанами под Копенгагеном, где Нельсон командовал авангардом. То есть Нельсон был, конечно, опытным флотоводцем, но он был вице-адмиралом, причем вице-адмиралом синего флага. Это младший из вице-адмиралов в английском флоте. Ну, поскольку старшинство адмиралов определялось только их временем производства в чин контр-адмирала. Дальше просто по мере умирания старших адмиралов остальные подвигались по службе. И Нельсону было, не было 50 лет, когда он 58 года рождения, значит, ему было 47, когда он дал свое последнее сражение при Трафальгаре и погиб. Но если характеризовать его как личность, то Нельсон был любим матросами и офицерами. Это редкий случай. И надо сказать, что Александра Васильевича Суворова, например, солдаты очень любили, а офицеры не очень. Там, того же Румянцева вообще не очень любили. Веллингтона вообще никто не любил. Я бы сказал, что его скорее ненавидели. И быть успешным военачальником и при этом снискать любовь подчиненных – это очень сложно. Потому что военачальнику приходится постоянно давить на подчиненных, но и любви это, как правило, не вызывает. Нельсон, тем не менее, был такой фигурой, которая вызывала любовь, и он умел вдохновить своих подчиненных. Вот здесь, может быть, параллель я бы привел адмирала Макарова Степана Осиповича, который тоже умел вдохновлять. И это было огромнейшим капиталом Нельсона, потому что если подчиненные верят в начальника, они выполняют его приказания без всякой задней мысли. А если они не верят, они начинают все время думать, а вот не дурак ли наш начальник, не ведет ли он нас к погибели. Кстати, это вот сковывало тех же французов во время Трафальгара, потому что Вильнёв не пользовался большим авторитетом среди офицеров. Младший флагман Нельсона Коллингвуд был старше его на 8 лет и пришел на флот на 10 лет раньше. Но был таким менее выдающимся начальником, но тоже, кстати, стал капитаном до 30-летнего возраста. Вообще, вот все адмиралы, о которых мы будем говорить, получили под команду первые свои корабли в 25-30 лет, что было, видимо, свидетельствовало о том, что их заслуги, их выдающиеся качества признавали современники на достаточно ранних стадиях карьеры. Если говорить о Вильнёве, то он был самым младшим из всех, о ком тут идет речь. Он 1763 года рождения. И выдвинулся он в связи с Великой Французской революцией, когда многие опытные офицеры оказались в эмиграции, кое-кто был репрессирован в результате террора, но Вильнёв выдвинулся. После Абукира он был произведен в адмиралы, но, в общем-то, как-то у Наполеона оказалось с кадровой линейкой на флоте не очень хорошо. И Вильнёв, наверное, во всяком случае, он не мог никого вдохновить и был человеком достаточно осторожным и таким, не то чтобы робким, но, во всяком случае, не дерзким. Нужен был для противостояния англичанам дерзкий адмирал. И адмирал Гравина, который возглавлял испанский флот, был, может быть, значительно одареннее и талантливее Вильнёва. Во всяком случае, Гравине удалось на конечном этапе сражения и после сражения принять ряд мер, которые были вполне целесообразны, до чего мы еще дойдем. И Гравина является одним из героев испанской морской истории, тем более, что ему оторвало руку во время сражения, и он через несколько месяцев умер от этой раны. Так что сражение унесло, в общем-то, всех. Нельсон был смертельно ранен во время сражения, Гравина умер через несколько месяцев, а Вильнёв был отпущен из английского плена и то ли совершил самоубийство, то ли был убит во Франции, уже возвращаясь на родину. Но его, конечно, ждало судебное разбирательство, безусловно. Наполеон был крайне недоволен произошедшим, что, в общем, вполне естественно. Но до сих пор споры о том, было это самоубийство или убийство, остаются актуальны. И еще важным моментом было то, что франко-испанский флот был объединен. Всегда, когда союзники действуют вместе, это всегда проблема, потому что у них всегда есть и языковый барьер, и есть трение, и к тому же испанцы чувствовали себя достаточно неловко будут поставлены под команду французов, тем более, что Гравина, например, был старше в чине, чем Вильнёв, и тем не менее у французов...
И, судя по всему, явно более дерзким и талантливым.
Да, и тем не менее ему на голову посадили Вильнёва. То есть это, конечно, не могло испанцев радовать и вдохновлять. Тем более, что было понятно, что, в общем, в этой войне все вкусные плюшки съест Франция, а Испании останутся объедки в лучшем случае. И испанцев, дух боевой испанцев был не слишком высоким во время Трафальгарского сражения. Но при этом, значит, что же произошло непосредственно перед сражением? После того, как 5 августа 1805 года Австрия объявила войну Франции и вторглась в Баварию, Наполеон принял решение отказаться от вторжения в Великобританию. Да, мы остановились на том, что Вильнёв 13 августа вышел из Ферроля в направлении Бреста, чтобы объединить эскадры. Но, встретив торговые суда, которые сообщили ему о приближении английского флота, он не рискнул с ним сражаться и решил уйти в Кадис. То есть на самый юг Пиренейского полуострова, очень далеко от Бреста. Это была, вероятно, главная капитальная стратегическая ошибка Вильнёва, которая потом потащила за собой все остальное, потому что фактически англичане подставились в данный момент. Английская эскадра действительно навстречу Вильнёву шла, но это было всего дюжина британских кораблей, которые, было всего 18 британских кораблей, которые шли навстречу 29 кораблям Вильнёва. Адмирал Корнуоллис английский, который командовал эскадрой, блокировавший Брест, послал 18 кораблей навстречу Нельсону, чтобы усилить его эскадру, полагая, что таким образом Нельсон сможет уничтожить эскадру Вильнёва. Но тем самым он подставился. Если бы Вильнёв продолжал движение на Брест, он бы встретился с 18, либо встретился с 18 кораблями и имел все шансы на победу, имея преимущество в 11 кораблей. Либо он мог бы с ними разминуться, и тогда он бы поймал самого Корнуоллиса, оставшегося с 16 кораблями перед Брестом, а в Бресте было еще 21 корабль адмирала Гантома. И тогда эта эскадра была бы раздавлена. И это дало бы шанс Наполеону на высадку в Англии. Но, с другой, кстати говоря, тут тоже вот все время говорят: высадка в Англии, высадка в Англии. Там Наполеон говорил: дайте мне 3 туманных дня, и я стану господином Лондона, парламента и английского банка. А что было бы потом? Представим себе, что Наполеон высадился в Англии, разбил сухопутную армию британскую, что было не очень сложно для Наполеона явно, занял Лондон и заставил англичан подписать мир. И даже, предположим, он заставил их выдать весь свой флот Франции. Экономическая мощь Англии никуда бы не делась. Промышленный переворот в Англии происходил быстрыми темпами и был близок к завершению в это время. И все равно через несколько лет Великобритания построила бы новый флот, и ситуация бы снова повторилась. То есть никакого радикального решения английского вопроса высадка Наполеона в Англии на самом деле не несла. Но сам Наполеон, наверное, не очень об этом догадывался. И, вероятно, он верил в возможность окончательной победы над Англией. Иначе зачем он вообще с ней воевал? Тем не менее, разворот Вильнёва на пути к Бресту окончательно дал понять Наполеону, что высадка откладывается. И он повел свою армию быстрыми переходами к Ульму, где внезапно появился и заставил капитулировать австрийскую армию Макка. Но это уже другая история. И теперь план Наполеона изменился. Поскольку эскадра Вильнёва оказалась в Кадисе, то Наполеон отдал приказ идти в Средиземное море и оказать помощь тому корпусу, который находился на южном побережье Италии, для высадки в Сицилии. Либо, возможно, для высадки на Далматинское побережье, там, возможно, были варианты. То есть в обоих случаях это должна была быть вспомогательная операция в той войне против Австрии, которая началась. Напомню, что Сицилия в это время не была оккупирована французскими войсками, в отличие от южной части итальянского сапога. И королевство обеих Сицилий оказалось на Сицилии в качестве английского союзника под прикрытием британского флота. И Сицилия служила британской военно-морской базой в течение дальнейшей войны. И Вильнёв, получив этот приказ, очень неохотно выходит из Кадиса и начинает движение в сторону Гибралтарского пролива. Тут же это произошло 19 октября, а через 2 дня произошло Трафальгарское сражение. При этом сам по себе Вильнёв крайне вообще, так сказать, не желал выходить в море и не верил в свои силы и в силы своего флота. Адмирал Гравина тоже был против выхода в море, кстати, потому что получалась ведь какая ситуация. Одно дело рискнуть 29 кораблями, или 33 даже кораблями, потому что в Кадисе в итоге собралось 33 корабля французов и испанцев, ради стратегической задачи высадки в Англии. Другое дело рискнуть ради вспомогательной операции в Средиземном море. Ну и к тому же Гравина говорил, что идет шторм с Атлантики. Было маловетренно, но была сильная зыбь, что было предвестником шторма. Но с другой стороны, если бы эскадра вошла в Средиземное море, эти проблемы остались бы по ту сторону Гибралтарского пролива. Итак, эскадра в довольно невнятном порядке, напоминающем кильваторную колонну, двигалась в сторону Гибралтара, когда с запада, со стороны Атлантического океана, к ней начали приближаться англичане. 27 английских кораблей. В принципе, у Нельсона тоже было 33 корабля. Но 6 кораблей были отосланы за водой и продовольствием. Одной из проблем англичан, которые блокировали французов и испанцев, было то, что нужно было регулярно подвозить воду и продовольствие. Или регулярно отсылать корабли за водой и продовольствием. Поэтому английские адмиралы все время напоминали жонглера, который жонглирует десятком шаров, и нужно ни один не уронить в этой сложной карусели. Но не говоря уже о том, что сюда прибавлялись штормы, прибавлялись всевозможные случайности. И это все давало, опять же, бесценный опыт британским офицерам и адмиралам. Ну и кроме того, это приучало британских моряков к тому, что нет ничего невозможного, и что любые трудности нужно преодолеть. И что какие-то рассказы про плохую погоду, про недостаток воды, они вообще никого не будут интересовать, когда дело дойдет до разбирательства в случае каких-то событий. Ну и у Нельсона был, конечно, план, безусловно. Но план этот был предельно простым. Эскадра была разделена на 2 колонны и резерв. Она была вообще очень длинная. 27 кораблей – это огромный хвост. Нельсон не собирался выстраивать параллельную колонну вражеской, он собирался атаковать перпендикулярно противника. Значит, 2 английские колонны и резерв, который должен был примкнуть к одной из них. Значит, идея была в следующем, что одна из этих 2 колонн, англичане называют их дивизиями или division. Плохие переводчики переводят это как дивизион. На самом деле корректный перевод дивизия – это термин, который использовался и в русском флоте. Но у нас вообще лучше говорить колонна все-таки, особенно в современном тексте, потому что дивизия для современного человека предполагает некое штатное соединение, имеющее штатную структуру. Здесь же имелось в виду именно колонна, собранная ситуативно из какого-то количества кораблей. Большая колонна должна была атаковать вражеский флагман, который, предполагалось, будет находиться в центре, и задержать, как минимум, половину вражеского флота, отсечь половину вражеского флота. А большая колонна должна была расправиться со второй половиной вражеского флота. Таким образом, Нельсон собирался добиться численного превосходства в направлении главного удара. Одна из аксиом стратегии. Ну и кто будет играть какую роль, должно было определиться тогда, когда будет видна вражеская эскадра. Там у нас есть 2 схемы, которые изображают эту идею Нельсона, их можно будет показать. И картина, изображающая момент сближения кораблей. При этом судьба распорядилась так, что Нельсону выпала задача сдерживать часть вражеской эскадры и командовать меньшей колонной, когда Коллингвуду достался резерв, и он должен был уничтожать большую колонну противника. Значит, что получилось на практике? У Коллингвуда было 16 кораблей, которыми он должен был атаковать 14 франко-испанских. У Нельсона же было 11 кораблей, которыми он должен был атаковать 19 кораблей противника. Но судьба благоволила Нельсону, когда английская эскадра была обнаружена, Вильнёв отдал приказ развернуться и уходить в Кадис. Вероятно, это было второй ошибкой Вильнёва уже тактического плана, потому что при повороте в маловетренную погоду и при сильной качке французские и испанские корабли не смогли построить кильваторную колонну. Ну, что было вполне предсказуемо. Но и, в общем, непонятно, на что надеялся Вильнёв, потому что уйти от англичан уже было невозможно. Максимум, на что он мог рассчитывать, это на то, что будет немножко ближе прорываться к Кадису, оставшимся после поражения своим кораблям. То есть, поражение, в общем, как бы сказать, заранее предполагалось. Но с таким настроением в бой идти не стоит. А при этом адмирал Дюмонуар, это французский младший флагман, который возглавлял арьергард, а теперь он возглавлял авангард после разворота, он начал выполнять приказ идти в Кадис, не обращая внимания на завязавшееся сражение. В результате 10 кораблей французского флота в течение почти всего сражения шли в Кадис. Только ближе к концу сражения Дюмонуар решил развернуться и пойти на помощь своим главным силам. всего сражения шли в Кадис. Только ближе к концу сражения Дюмонуар решил развернуться и пойти на помощь своим главным силам. Да и то он держал гораздо западнее, чем нужно. И только, видимо, не собираясь вступать в бой. То есть, собираясь сохранить для Франции хотя бы остатки флота, я бы так сказал. Но один из командиров линейных кораблей французских устремился в сражение, увлек за собой еще 6 кораблей.
То есть, дерзкие все-таки были?
Были, да, конечно. Но почему-то они в адмиралы вот как-то или теряли дерзость, становясь адмиралами. Вот какая-то была странная такая история. И в итоге 6 кораблей французского авангарда все-таки приняли участие в сражении. Но это сильно облегчило Нельсону задачу. Вместо того, чтобы сдерживать 19 кораблей франко-испанских с 11 своими кораблями, Нельсон в начале боя имел дело только с 9 франко-испанскими кораблями. И только потом подошли еще 6. То есть, таким образом, Дюмонуар дал возможность Нельсону еще и бить по частям франко-испанский флот.
Красавчик.
Соответственно, испанцы же оказались в арьергарде. Ну, и испанцы, кстати говоря, действовали более целенаправленно, возможно, в какой-то степени, потому что они прорывались через английский флот в сторону Кадиса. Но в любом случае, испанцы действовали, на мой взгляд, более слаженно, чем французы в этом сражении, и, может быть, даже показали себя лучше, чем французы, хотя вообще французы всегда относились к испанскому флоту достаточно презрительно и, как бы сказать, так, пренебрежительно похлопывая его по плечу.
Ну, понятно, как и англичане.
Да, значит, соответственно, как разворачивается сама битва? Нельсон на своем флагманском корабле «Викторе» атакует флагманский корабль Вильнёва, который назывался «Буцентавр». Но поскольку франко-испанская колонна не была колонной кильваторной, а корабли были разбросаны на некотором пространстве, то он сначала свалился на абордаж с французским кораблем «Редутабль». У Нельсона распоряжения были следующие. Он описал ситуацию 2 колонн и дальше написал, что ни один капитан не ошибется, если подойдет вплотную к неприятелю. Угу. То есть, задача была поставлена каждому капитану во время сражения не смотреть на сигналы адмирала, не, как бы сказать, ориентироваться на другие корабли, а подходить вплотную к ближайшему кораблю противника и уничтожать его или захватывать. Ну и, собственно, все командиры кораблей были на это целеустремлены, как выражаются военные. Нельсон на «Викторе» подавал, понятное дело, пример. Он свалился с редутаблем на абордаж. И вот тут-то французский стрелок с Марса смертельно ранит Нельсона. Пуля вошла в плечо, застряла в позвоночнике, и Нельсон с такими повреждениями тогдашняя медицина была бессильна бороться. Он умер спустя приблизительно 2,5 часа после ранения, в 16 часов 40 минут, потому что сражение началось в 13 часов. При этом Нельсон был унесен вниз, потому что на верхней палубе кипел бой, но он все время интересовался, как идет дело, понятное дело. Но гибель адмирала, которая могла бы иметь фатальные последствия вообще для флота, их не имела, потому что Нельсон отдал правильный приказ. Каждый капитан уничтожает ближайшие корабли противника. Чем английские корабли и занялись.
Кто сменил Нельсона? Кто
Нельсона
принял
формально, конечно, адмирал Коллингвуд. Но Коллингвуд узнал о выходе Нельсона из строя к концу боя. Потому что в пороховом дыму просто никакие сигналы были не видны. Кстати, о сигналах. У нас есть картинка, которая изображает сигнал знаменитый. England expects that every man will do his duty. То есть, Англия ожидает, что каждый исполнит свой долг. Причем, это была еще не современная семафорная азбука, когда один флаг означает одну букву. Это была более сложная система. Причем, первоначально Нельсон хотел дать сигнал: Англия верит, что каждый исполнит свой долг. Но сигнальный лейтенант сказал, что слово «верит» нет в словаре сигналов. И его невозможно показать трехфлажным кодом. А нужно набирать по буквам. Более того, слово «долг» тоже не было в словаре. Но Нельсон сказал: слово «долг» наберите по буквам. И, соответственно, этот сигнал был поднят. Ну и с тех пор английские флагманы поднимают в начале сражения первые 2 слова этого сигнала. Англия ожидает. Или Англия ждет, но все понимают, о чем идет речь.
Интересно.
Вот, это такая красивая история. Кстати, она показывает, насколько совершенной стала система сигнала производства. Скажем, Ушакову невозможно было поднять такой красивый сигнал, потому что у нас вообще не было в тот момент системы сигналов, которые позволяли набирать фразу из слов. Можно было только обозначать приказания в целом. Ну, там, например, гнать к югу, или построить кильваторную линию, там, или бросить якорь, там, или командирам всех кораблей приехать на флагман и так далее. То есть ничего красивого вот у нас поднять было невозможно. Если бы Ушаков даже хотел это сделать, он бы это не смог. У нас была перенята именно в эти годы английская система сигналопроизводства. Кстати, почти на каждом английском корабле был русский офицер. Наших офицеров было довольно много на стажировке в Англии и в качестве волонтеров, но они имели чины мичманов обычно русского флота, но в Англии они проходили как волонтеры, то есть люди, не имевшие офицерского чина, находились почти на каждом английском корабле и принимали участие в этом сражении, набирались боевого опыта.
Какие-то известные люди?
Ну, нет, вот никто из известных людей, как-то из них не вышел. Из очень известных людей Михаил Петрович Лазарев стажировался в английском флоте, но в Трафальгар он не попал. В силу обстоятельств.
Было бы красиво.
А так было бы красиво, да, конечно. Да. Но его бы называли там каким-нибудь духовным сыном Нельсона. Вот. Но нет, он справился и без этого.
А вот такой вопрос попутно. Все-таки часто приходится слышать, что Нельсон существенной роли в победе английского флота и не сыграл, так как вышел из строя практически в самом начале. Вот все-таки, судя по тому, что вы рассказали, он всю работу сделал до начала и в самом начале сражения, и поэтому
совершенно верно. Хороший полководец,
его вклад неоспорим.
Хороший полководец так и поступает. Ну, я бы начал с того, что он еще в конце XVIII века сплотил своих командиров кораблей и называл их «банда братьев». Но это может быть неудачный перевод, потому что слово «банда» в русском языке имеет негативную коннотацию. Ну, какая-то команда братьев, «band of brothers». Это было особым таким, ну, как бы сказать, духовным родством и взаимопониманием без слов. То есть добиться того, чтобы твои подчиненные понимали тебя и друг друга без слов, это важнейший элемент хорошо организованной вооруженной силы. Это как вот немецкому генеральному штабу в конце XIX века удалось добиться того, что немецкие офицеры штабные понимали друг друга без слов и могли, скажем, планировать взаимодействие, не общаясь друг с другом, но просто одинаково видя картину боя. Это крайне важно. Это вот в эпоху Мольтке стало одним из сильнейших козырей немецкой армии. И Нельсон, как бы сказать, воспитал тех командиров кораблей, которые победили в Трафальгарском сражении. Если бы они не доверяли Нельсону, не доверяли друг другу, сомневались в приказаниях, которые отдает Нельсон, они бы не лезли на рожон, на пистолетный выстрел и на абордаж.
Ну, то есть победила вот эта банда братьев, команда
совершенно
Нельсона.
Верно, да. А плюс к этому еще и рядовые матросы очень верили в Нельсона. Но тут был, конечно, такой скорее стихийный народный момент. И верили в Нельсона как некий талисман, как русские солдаты верили в Суворова. Вот. Но это тоже позволяло каждому прикладывать максимум усилий. Потому что каждый понимал, что Нельсон там, или Суворов плохого не прикажет. То есть он ведет нас к победе. И мы просто прилагаем усилия, и победа в наших руках. Собственно, что в итоге и получилось. Значит, я тут должен сразу сказать, что смерть Нельсона тоже стала легендой. И вокруг нее возникла масса мифов. Например, существует миф о том, что черные ленточки на бескозырках матросов всего мира, ну и в частности английских матросов, это вечный траур по Нельсону. Это красивая легенда, потому что ленточки на шляпах, такие развивающиеся, они появились в 20-30-е годы 19 века. При Нельсоне мало кто из английских моряков носил ленточки на шляпах. Обычай писать название корабля, кстати, на этих ленточках тоже появился в самом конце наполеоновских войн. И нет оснований считать, что эти ленточки как-то связаны с английским этим великим адмиралом. Но с точки зрения почестей, которые были оказаны ему после смерти, наверное, ни один британский адмирал такого не удостаивался. Он удостоился государственных похорон. Он был похоронен в соборе Святого Павла, фотографию его гробницы можно видеть. В честь него был создан главный архитектурный комплекс Лондона – Трафальгарская площадь. Потому что в Лондон, вообще говоря, это большая деревня с архитектурной точки зрения. И, скажем,
Я согласен
с Петербургом никакого главный архитектурный комплекс Лондона, Трафальгарская площадь. Потому что в Лондон, вообще говоря, это большая деревня с архитектурной точки зрения. И, скажем,
согласен
с Петербургом никакой, даже с Москвой даже никакой
не стоит.
Нет
Я был
сравнения.
в шоке.
И в Лондоне, простите, прямую улицу можно с трудом найти, там небольшой отрезок, там у них все кривое и косое. Но Трафальгарская площадь действительно это такой главный, может быть, единственный архитектурный ансамбль, в центре которого стоит колонна, увенчанная фигурой Нельсона. То есть ему оказали императорские почести. То есть надо понимать, что в Европе того времени еще жива была вся эта иерархия. И в России, скажем, ну и как и в других странах, конные памятники полагались монархам, пешие памятники не монархам. И у нас Суворов в пешем строю запечатлен на памятнике, потому что он не монарх. Так же, как Кутузов и Барклай де Толли. Это пешие памятники. А конные памятники императорские. Но колонна с фигурой на верху – это исключительно императорский памятник. И Нельсон таким образом был удостоен невероятно высокой почести. Но и кроме того, его имя стало просто легендарным в английской истории в целом. И корабль «Виктори», который сохраняется до сих пор как памятник Нельсону и Трафальгарскому сражению. Причем «Виктори» остается кораблем номер 1 британского военно-морского флота. И до сих пор назначается командир этого корабля и команды. Это офицеры действительной службы. И до сих пор «Виктори» считается...
стоит где-то на приколе или это музей?
Он стоит... Это музей. Он долгое время стоял на воде до конца 19 века. Но потом стало понятно, что он так долго не простоит. Его поставили в сухой док. А потом сухой док засыпали. И сейчас он стоит такой закопанный в землю, но там под ним довольно сложная система гидроизоляции, которая позволяет корпус корабля сохранять. Вот. Но на него пускают экскурсии. Там, правда, посещение возможно только в сопровождении, но можно походить по этим доскам. Я там был и ходил, и видел место, отмеченное крестом, где умер Нельсон, положенное на палубу. Вот, это, ну, правда, там, конечно, видно довольно мало, темно, тесно, электрической проводки там нет, освещения там естественное, ну, чтобы пожары не устроить на Викторе, понятное дело. Но экскурсию водит моряк, действующий английского флота, и все это производит довольно сильное впечатление. Но понятно, что рангоут на Викторе упрощенный, там стоят только нижние колена мачт, чтобы вся эта система не давила на корпус, но тем не менее впечатление производит довольно сильное. Тем более, что рядом стоит на воде первый железный английский броненосец Warrior, построенный через 100 лет после Виктории, и там уже полностью воспроизведены все внутренности, там и артиллерийская батарея, которая мало чем отличается от батареи Виктории. И этот Warrior служит хорошей иллюстрацией. А теперь появился еще третий музей корабля Мэри Роуз, который затонул в 16 веке, который подняли и который долго реставрировали, долго консервировали, но сейчас в специальном здании, построенном рядом, выставили. Это крайне интересный комплекс в Портсмуте, такой музей. Значит, теперь давайте посмотрим на результаты сражения. Значит, у нас, благодаря еще ошибкам французского адмирала Дюмануара, сначала англичане имеют 27 кораблей против 23 франко-испанских. Ну, а потом силы после подхода 6 кораблей авангарда вроде бы сравнялись, но уже часть испанских и французских кораблей были захвачены англичанами. То есть, фактически, превосходство флот союзный не имел над английским. Хотя и победа в равных силах – это, знаете, очень достойно. Тем более, что у испанцев было несколько кораблей более крупных, чем английские. У них была Сантиссима Тринидад 136-пушечная, 2 112-пушечных корабля. А крупнейшие, 7 крупнейших английских кораблей несли от 98 до 104 пушек. Но, правда, у англичан и маленьких кораблей было больше. У них было 3 64-пушечных корабля, а у французов у испанцев, всего один такой корабль. У французов корабли были 80 или 74-пушечные. Это вообще самый стандартный такой линейный корабль эпохи. Значит, но как распределились потери? Значит, англичане в результате сражения нанесли союзному флоту огромные потери. В общей сложности был потерян 21 линейный корабль. И еще 4 корабля, которые не участвовали в сражении, которые Дюмонуар повел в Рашфор, были перехвачены другой английской эскадрой, и все 4 захвачены. В общей сложности 25 кораблей погибло и было захвачено из 33. Это, конечно, гигантский разгром, это почти полное уничтожение флота. Тем не менее, судьбы кораблей этих сложили... Да, англичане не потеряли ни одного своего корабля при этом.
Ну, это, конечно, грандиозный успех.
Это грандиозный успех, да. Значит, но первоначально к вечеру 21 октября были захвачены 9 испанских и 8 французских кораблей. Всего 17. Один французский корабль сгорел. Однако Гравина, достигнув Кадиса со своими кораблями, с остатками испанского флота, приложил титанические усилия. Корабли были исправлены. Они переждали 22 октября в гавани, потому что 22 октября был сильнейший шторм, в ходе которого потонуло 5 захваченных кораблей. Ну и вывел свою эскадру, чтобы отбить часть кораблей у англичан. И действительно, он смог отбить 3 испанских корабля. Причем на корабле Санта-Ана еще случилось восстание. Испанская команда восстала, перебила английскую призовую команду и присоединилась к эскадре Гравин. Но, правда, из 3 отбитых кораблей только Санту-Анну удалось довести до Кадиса, а 2 других были настолько сильно повреждены, что были выброшены на берег. Потому что 23 октября шторм продолжался, хотя и менее сильный, чем 22.
Но это тоже героическая
безусловно,
история.
Учитывая, что у Гравины была оторвана рука.
Скажите, а это вошло в часть испанского национального
да,
мифа?
Да, безусловно. И более того, есть и современный писатель Артуро Перес Реверте написал роман «Трафальгар», но и такой Перес Гальдос, классик испанской литературы, писатель середины XIX века, написавший патриотическую серию из 30 романов о каждом сражении войны с французами на Пиренейском полуострове. Он написал о Трафальгаре. Причем там интересный прием у Перес Гальдос, но он довольно скучный по современным меркам Перес Гальдос, конечно. Ну, впрочем, как, в общем, такая любая старая литература. Но у него такой прием: один и тот же человек участвует во всех этих событиях. И только в Трафальгаре он не участвует, потому что он в сухопутной армии. И ему рассказывает его приятель про Трафальгар. То есть Трафальгарское сражение в испанской традиции это как Цусима в нашей, наверное. Это некий героический такой акт, который не закончился победой. Но, тем не менее, весьма достойно. У испанцев погибло очень много командиров кораблей. Их почти половина командиров кораблей погибло. Были очень высокие потери личного состава. На некоторых кораблях они доходили чуть ли не до 80%. Но у англичан максимальные потери в процентном отношении это 30-35% убитыми и ранеными. Это чудовищные потери для парусного корабля, который не утонул. На Викторе было 19% экипажа убито и ранено, 57 убитых, в том числе Нельсон, и 102 раненых. Причем раненые считались тяжелые. Конечно, царапины никто не собирался учитывать. И у нас есть несколько картин, изображающих саму битву классических и смерть Нельсона. Вот их тоже можно показать. Значит, но если говорить о последствиях Трафальгара, то последствия, конечно, материальные были довольно тяжелыми. Потеря 25 в общей сложности линейных кораблей подорвала силы французского и испанского флотов. Но психологические последствия Трафальгара были еще более сильными. С одной стороны, французские моряки окончательно, сложили крылья и окончательно разуверились в своей возможности бороться с англичанами. С другой стороны, Наполеон разуверился в возможностях своих моряков. И и потом у Наполеона объективно после этого уже не было длительной передышки в несколько лет, в течение которой он мог бы посвятить свои силы строительству флота, восстановлению флота. В целом Наполеон после этого оказывается увлечен сухопутными компаниями, неважно, в конце концов, по своей вине он оказался в них увлечен или втянут в них обстоятельствами, это не столь существенно. Но действительно, вплоть до 1815 года у Франции уже не было возможности восстановить большой линейный флот. Тем более, что чтобы его восстановить, нужно было перегонять корабли от мест постройки куда-то, сосредотачивать их в каких-то портах, а англичане все время этому препятствовали. И в целом после этого господство на море оказалось в руках британцев. И дальше до 15 года мы имеем несколько, более-менее крупных стычек, нескольких кораблей между собой, но вот таких крупных морских сражений мы больше не видим. И действительно, Трафальгар в английской историографии превратился в такой миф, в сражение, в котором британский Геркулес, так сказать, задушил французскую гидру, и после этого эта гидра уже Англии не угрожала. Но надо понимать, что Франция потерпела поражение в наполеоновских войнах на суше. Если бы Наполеону удались его замыслы, если бы ему удалось, скажем, нейтрализовать Россию или договориться с Россией каким-то образом, то ничто не мешало Наполеону бросить средства для постройки кораблей и строить их, например, в Балтийском море, в зависимых от него германских землях, а там оттуда уже переводить большими эскадрами в Атлантику. Ему, в общем, мог бы, например, он присоединить русский флот к своему, даже если бы он достиг с Россией какого-то, соглашения.
Мог бы быть возрожден павловский прецедент.
И, конечно, чуть ли не план похода в Индию мог быть возрожден. Или если бы Наполеону удалось сделать Россию младшим партнером, нанеся ей поражение. Но таким образом все равно Британия оставалась, без адекватного противника на море только потому, что силы Франции оттягивали сухопутные предприятия, а не потому, что силы Франции были уничтожены. Но, тем не менее, Трафальгарское сражение остается одной из жемчужин военно-морской истории, и никто не собирается оспаривать это утверждение, и оно позволяет ярко показать, на чем на самом деле зиждилось военно-морское искусство, такое высокое парусных флотов, впрочем, и паровых, на хорошей подготовке личного состава, на целеустремленности этого личного состава, на правильной подготовке сражения. А дальше в ходе сражения нужно было пожинать плоды подготовки к нему, что англичан вполне успешно удалось.
Отлично, Кирилл Борисович, очень интересно. Про что в следующий раз?
Возможно, что дальше у нас речь пойдет о Семилетней войне на море, потому что Семилетняя война с историей этого неудавшейся высадки в Англию, которая была сорвана 2 морскими сражениями, а не отвлечением Франции на сухопутные дела у Лагоса и в Киберонской бухте, достойна того, чтобы о ней поговорить.
Отлично. И в завершении, я думаю, нам надо дать анонс вашей экскурсии, которая планируется по югу нашей страны.
Егор Николаевич предложил, и как-то это все уже у нас вырисовывается, с 10 по 17 июля должна состояться поездка из Геленджика в Керчь через Новороссийск и Таманский полуостров, с посещением Новороссийска и мест, связанных и с гибелью эскадры в 18 году, и с Малой землей, и крейсера Михаил Кутузов, который там стоит послевоенный. Проезд через Анапу, там есть очень такие жалкие, я бы сказал, остатки турецкой крепости XVIII века, посещение на Тамане этнографического парка, посвященного кубанскому казачеству, и дальше Крымский мост и Керчь, где есть и аджимушкайские каменоломни, это потрясающий памятник истории Великой Отечественной войны, в котором, конечно, мы побываем. Это и турецкая крепость Еникале, это и русская крепость середины XIX века, запроектированная Татлебеном. Это и гора Митридат с античным Акрополем и историей Керченского десанта времен Великой Отечественной войны. И, конечно, будут элементы пляжа, теплое море, я надеюсь, хорошая погода, купание, посещение каких-нибудь гастрономических заведений приятных. Я надеюсь, что эта поездка у нас состоится. А я должен выступать по инициативе Егора Николаевича в качестве говорящей головы, которая будет...
Очень хорошо и интересно говорящей головы, как
спасибо,
я бы сказал.
Спасибо. Да. Будет развлекать на маршруте публику.
Дорогие друзья, ознакомиться с подробной программой можно цифровой истории теперь маршруты не только в Петербурге. Так что присоединяйтесь к нам. Ну что ж, спасибо большое, с нетерпением ждем продолжения.
Спасибо, Игорь Николаевич. Спасибо.
One would think that the two sciences could hardly be further apart. In all hierarchical schemes, they are put far apart. Psychology, to everyone who works in the field, is felt to be a new subject in which real progress and real objectivity are recent. Physics is perhaps as old as the sciences come. Physics is reputed to have a large, coherent, connected corpus of certitude. This does not exist in psychology, and only the beginnings of it, the beginnings of things that are going to be tied together, are now before us. But I have always had a feeling that there were ways in which the two sciences had a community. Of course, all sciences do. One very simple one is that each is responsive to a primitive, permanent, pervasive human curiosity. What material bodies are and how they behave on the one hand, and how people and the people-like animals behave and feel and think and learn. These are the curiosities of common life, and they'll never be abated. Both for this reason can hardly make important pronouncements of a technical sort, which do not appear to have some bearing on our views of reality, on metaphysics. Both manifestly have and continue to have a fresh and inspiriting effect on the theory of knowledge, on epistemology. There are other ways in which we are brothers. In the last 10 years, the physicists have been extraordinarily noisy about the immense powers which, largely through their efforts, but through other efforts as well, have come into the possession of man. Powers notably and strikingly for very large scale and dreadful destruction. And we have spoken of our responsibilities and of our obligations to society in terms that sound to me very adolescent, because the psychologist can hardly do anything without realizing that for him the acquisition of knowledge opens up the most terrifying prospects of controlling what people do and how they think and how they behave and how they feel. This is true for all of you who are engaged in practice. And as the corpus of psychology gains in certitude and subtlety and skill, I can see that the physicist's pleas that what he discovered be used with humanity and be used wisely will seem rather trivial compared to those pleas which you will have to make and to which you will have to be responsive. The point, of course, is that as the relevance of what we find to human welfare and human destiny becomes sharper and more manifest, our responsibilities for explication, for explanation, for communication, for teaching, our responsibilities for being sure that we are understood grow. Not our responsibilities for making decisions, but our responsibilities for laying in a responsible way the basis of those decisions. There are other ways in which we are alike. The practical usefulness which our professions have gives us often the impression that we are liked for the wrong reasons and that our true nature is very different from our public presence. We are both faced with the problem of the need to keep intact the purity of academic and abstract research, and at the same time to nourish and be nourished by practice. In physics, of course, our debt to technology, to engineering, is unlimited. I think it will be so in psychology as well. But there is no doubt that in our present state, we have parallel tensions. Both sciences, all sciences, arise through refinements, corrections, and adaptations of common sense. There are no unique, simple scientific methods that one can prescribe, but there are certainly traits that any science must have before it pretends to be one. One is the quest for objectivity, and that I think I mean not in a metaphysical sense, I mean in a very practical sense. The quest to be sure that we understand one another and that all qualified practitioners mean essentially the same thing. Common sense language is inherently ambiguous. When the poet uses it, or the rhetorician, he exploits the ambiguity. And when we talk in ordinary life, we almost need the ambiguity in order to get by. But in science, you try to get rid of that. You try to talk in such simple terms and match your talk with deeds in such a way that we may differ as to facts, but we can resolve the differences. And this is, of course, the first step in the quest for certitude. But certitude is not the whole story. When you move from common sense into scientific things, you also move toward generality, using analysis, using observation, and in the end using experiment. And you do something which is even more, I think, characteristic. You look for novelty. you look for transcendence. That is, you look for features of experience that are not available in ordinary life. Characteristic in physics are the instruments that enable us to transcend elementary daily experience. The telescope that lets you look into the sky, today the enormous accelerators, which are in fact the logical extension of the microscope that enables you to look finer and finer into the structure of matter. I would like to be cautious in the parallels in psychology, but certainly the use of hypnosis, the use of drugs are typical extensions into unfamiliar realms of human experience, which just bring out characteristics of psychological phenomena that are too lost in the day-to-day experience. There is an example which is a physicist's idea of a perfect experiment. It is the work that was done in McGill in the last years on, and I'm sure you have discussed it, on the effects of reducing sensory stimuli. Very simple arrangements to change the level of stimulation. And these produce evocative and, I would say, almost frighteningly great changes in memory, in the intellectual and cognitive life of the people who undergo them. Well, this is again an example of carrying to an extreme something which is encountered in ordinary experience, but which only the patience and the abstractness of experimental inquiry is likely to realize. We come from common sense, we work for a long time, then we give back to common sense refined, original, and strange notions, some of which I want to talk about today, and enrich what men know and how they live. And there, I suppose, the real hero is the teacher.
Leave that to me.
I chose as my theme analogy in science. Really what I'm going to talk about is analogy, and to a much lesser extent, some slight traits of analogies between the sciences. Mostly, this second theme has led to misunderstanding and limitation. But as for the first, analogy is an indispensable and inevitable tool for scientific progress. And I perhaps had better say what I mean by it. I don't mean metaphor, I don't mean allegory, I don't even mean similarity, but I mean a special kind of similarity, which is a similarity of structure, a similarity of form, a similarity of constellation between two sets of particulars, two sets of circumstances that are manifestly very different, but have this structural parallelism. It has to do with relation and interconnection. I'd like to quote you a scholastic comment on analogy. It's a translation of Penido. In a very general sense, every analogy presupposes two ontological conditions. One, a plurality of real beings, and thus among them, an essential diversity. Monism is the born enemy of analogy. And two, at the very heart of this multiplicity, of this inequality, a certain unity. It is a matter which we could argue as to whether these structural elements are invented by us or whether they're discovered in the world. I find it very artificial to say that they are invented, and mean by that they are more artifact than the particulars which they unite and describe. I may tell one incident in the long history of astronomy and physics. which makes this very vivid for me. For practical purposes, prophecy and ritual, the Babylonians worked out a method of predicting what days the moon would first be visible, and lunar eclipses and certain rarer astronomical events. They did this by purely mathematical methods. They observed when the things happened and they got the pattern of it. It's something that you might recognize as harmonic analysis. And they were very good. They got so good that their methods were in use last century in India, and the people were predicting eclipses within 30 minutes, which is not bad at all, using these 2,000-year-old methods. They not only got very good, but they enjoyed it very much, and they did it for fun. Long after the practical reasons had gone away, they published these tables, apparently as we publish articles on the internal constitution of the stars, because it's interesting. They did all of this without any celestial mechanics, without any geometry. Nothing moved. There were no objects circulating around in orbits. There were no laws of motion. This was just from the feel of the numbers. Well, you know how today we predict eclipses and first risings. It would seem to me very wrong to pretend that the mathematical regularities, which were the basis of the Babylonian predictions, were something they invented. It would seem to me equally wrong not to recognize in celestial mechanics, as we now know it, a far deeper and more comprehensive description of regularities in the physical world. And I think not only because it's a little more useful, I think that not only because it unites more subjects, but because it reveals an aspect of the regularities of the world which was wholly lost to the Babylonians. But whether or not we talk of this as discovery or as invention, analogy is an inevitable human thing, because we come to new things in science with what equipment we have, which is how we've learned to think, and above all, how we've learned to think about the relatedness of things. We can't, coming into something new, deal with it except on the basis of the familiar and the old-fashioned. The conservatism of scientific inquiry is not an arbitrary thing. It is the freight with which we operate. It is the only equipment we have. We can't learn to be surprised or astonished at something unless we have a view of how it ought to be, and that is almost certainly an analogy. We can't learn that we've made a mistake unless we can make a mistake, and our mistake almost always is in the form of an analogy to some other piece of experience. I'm not trying to say that analogy is the criterion of truth. You can never establish that a theory is right by saying that it's like some other theory that's right. The criterion of truth must come from analysis and confrontation with experience, and from that very special kind of objectivity which characterizes science, namely that we're quite sure we understand one another and that we can check up on one another. But truth is not the whole thing. Certitude is not the whole thing in science. Science is an immensely creative and organizing and enriching experience, and it's full of new things. And it is in order to get to these that analogy is an indispensable instrument. Even analysis, even the ability to plan experiments, even the ability to sort things out and take them apart, presupposes a good deal of structure, and that structure is characteristically an analogical one. I'm not pulling a political stunt. I want to read you now just a few words which William James wrote, which say this awfully well. He wrote them in one of his later accounts of pragmatism at a time when his own good sense and shrewd observation and wisdom and humanity made him aware of the fact that just to say that an idea was true because it worked was a rather poor description of what went on in science, and that something was missing from that account. This is what he wrote. The point I now urge you to observe particularly is the part played by the older truths. Failure to take account of it is the source of much of the unjust criticism leveled against pragmatism. Their influence is absolutely controlling. Loyalty to them is the first principle. In most cases, it is the only principle. For by far the most usual way of handling phenomena so novel that they would make for a serious rearrangement of our preconception is to ignore them altogether, or to abuse those who bear witness for them. This for the conservatism and the inevitability of starting out when you're talking about new things by supposing that you have seen them before, and then finding out in sharp, precise, and one hopes synoptic ways where the mistake was in the analogy and what has to be set right about it. I'll read you one other thing. This is from Charles Peirce, and then I'll get on with my talk. Peirce is also talking pragmatism, and he comes awfully close to what we have been talking about. And then he says, however, as metaphysics is a subject much more curious than useful, the knowledge of which, like that of a sunken reef, serves chiefly to enable us to keep clear of it, I will not trouble the reader with any more ontology at the moment. What I want to do next is to give you 5 examples of the use of analogy in atomic physics. They will not all be equally familiar. Perhaps that's an overstatement. Some are very new, and even to the point new that I don't know how good the analogies are, and we haven't yet found all the decisive point at which they're misleading. The analogies in physics may very well be misleading for biologists, psychologists, because of the enormous part that rather rigid formal structure plays in physics. Not necessarily quantitative, though much of it is quantitative, but our ability to write down synoptic relations in symbolic form, our use of shorthand, enables us to talk of vast amounts of experience, very varied experience, very detailed experience, in a shorthand way, and to point to mistakes so that you only erase one letter and everything is changed entirely. That can be a little bit misleading. This is not meant as a paradigm, but nevertheless as an illustration of the fact that in what is regarded as the most rigorous and certain of the sciences, we use an instrument which has been in great disrepute because uncritically used, it can confuse invention with confirmation and truth. I'd like to give a first example, which is not from atomic physics, which is almost from pre-physics, because it deals with things that are very familiar and yet illustrates the nature of the role of form in the use of analogy in physics. This has to do with Jean Buridan and the Paris school in the 14th century. The classic view, and physics has a special meaning for the word classic. Classic means wrong, but it means the wrong view that was held to be right a little while ago. The classic view was that the natural state of matter was rest, and that where you found bodies moving around, you needed to look for a cause, and this cause was a force. And this was the schoolman's view, it was Aristotle's view. It is in fact supported by an awful lot of observation. it was not well supported by the observation on projectiles. The notion that the air behind a bullet pushed the bullet became less plausible the more you watched the bullet. And Buridan and his many anonymous thinkers took a step which was to make a new analogy, and which probably was the greatest step in the history of Western science. They said, it is true that matter has a natural state, but it is not rest. It is true that when it departs from this natural state, it can be ascribed to the intervention of a force. But the natural state is one of constant impetus, one of constant momentum, one of uniform velocity. And with that, the beginnings of rational mechanics and of rational physical science were made. What do you do? Well, there isn't a blackboard here, but if there were, you simply replace the coordinate by the velocity. It is a small change, and yet it's the change in the whole way of thinking about the physical world. Well, my 5 illustrations from atomic physics, I will mention what they are. They are what has happened to the idea of waves, what has happened to the idea of classical physics in the atomic domain, the so-called correspondence principle, the analog between radioactive decay and the emission of light, which we owe to Fermi, the analog between electromagnetic phenomena and forces and nuclear forces, between electrodynamics and mesodynamics, and a final subject, which I will only call strangeness, because that's about all I know about it. Well, take the wave business. It originated, of course, in the observation of regular, rhythmic changes in matter, waves on water, and was followed by an easily conducted physical exploration of sound waves, where there is a periodic change, a regular change in the density of air or whatever the sound is passing through. Both of these phenomena exhibit a characteristic. If two waves collide, they can cancel each other out, and they can reinforce each other. They show interference. They have another abstract property. If you put waves through an orifice or around an obstacle that is small compared to the wave, then the obstacle or the orifice doesn't cast a sharp shadow, but there are all kinds of interference effects which are called diffraction. Waves superpose. If you have two, the sum of the two waves is just what you get by adding algebraically and not arithmetically. You get a zero if you add a positive and negative, which is the interference. And this is the abstract set of properties which has persisted. Because light is also a wave motion, but there is no matter in motion. There is no substrate. It was for a long time thought there was, and it was a great sign of progress in the 19th century to get rid of that. What is in motion are themselves physically measurable things, but rather abstract things, electric fields and magnetic fields. But again, interference, diffraction, and superposition, the same abstract characteristics, and again in principle, the infinitely regular, infinitely repeated pattern as a special case of a wave. And the most extreme examples are the waves of atomic mechanics, of wave mechanics, because these waves, in the first place, are in multidimensional space. They are represented by complex numbers, so there are not even things that you could measure and get an answer to, and they are quite unobservable. There is nothing to measure in the physical world that corresponds to these waves. They are connected with observation, but they have, again, these same abstract properties: interference, linearity, superposition. And one talks about them, one uses much the same mathematics, although it is not the fact that one can use the mathematics, but the fact that the structure and the relations are the same that is the decisive discovery, and then it is natural to use the mathematics. These waves, they represent if one wants to say what they are, not matter, not forces, not electric fields, they represent essentially a state of information about an atomic system. But at each point, the first workers have tried to make the theory like the earlier theory. Light like sound as a material wave, matter waves like light waves, like a real physical wave. And in each case it's been found that one had to widen the business a little bit and find the disanalogy which enabled one to preserve what was right about the analogy. The second example is a massive one. It is, I think, the greatest experience in this century for the physicists, even greater than relativity, and that is the discovery of atomic mechanics. And here again, in a sense very characteristic of scientific theory, an enormous conservatism presided over and guided the development and has given it shape. Well, what is all this about? When one gets to the atomic domain, and this is a domain of small actions, of limited distances and limited impulses, of things such as you encounter in atoms and nuclei, then the coarseness of the whole physical universe, its granular or atomic structure, for the first time begins to manifest itself. Not the granulation of the fundamental particles, but the granulation of atomic physics itself, of the quantum of action. There are aspects of it which are accessible to experiment, but are not compatibly or simultaneously accessible to experiment. The famous example is in the uncertainty relations, that you can study this location of something in time and space. But if you do that, you use an experimental setup which makes it impossible to know exactly what the impulse or velocity or energy of the system is. Or you can do the opposite. You can study the impulse, but then you lose account of where it is. And you can, of course, compromise, but you cannot combine. And one calls these the complementary aspects, complementary character of the fundamental observations. And that means that you can't talk about an atom as you can about a classical mechanical system. You can't say the objects in it are here and they're moving in certain orbits and so on. In fact, in ordinary atoms, there are no orbits in atoms as they're ordinarily encountered. There's something entirely different. Stationary states, which have a stability, a uniqueness, a reproducibility, which has no counterpart in classical physics at all, which couldn't exist if it were not for this revolutionary new feature. And one can talk about these stationary states, one can describe them accurately, but one has a whole change from the familiar experience of bodies in motion, of matter in motion. Sometimes people say that this atomic theory is characterized by the fact that you can't observe a system without disturbing it. But that's not quite right. It isn't the disturbance which makes the trouble. It's the fact that the means of observation would be frustrated as means of observation if you tried to take an account of the disturbance that you are making. It's a slightly more subtle point. Sometimes people say that the electron has a position and momentum, but you can't measure them simultaneously. But this isn't right either, because only the act of observation, the coupling of the atom with the physical measuring equipment, makes it logically permissible to attribute a position to an electron. You can't get the right answer by saying, well, it has a position, I don't know what it is, let me average. If you do that, you get a wrong answer. You have to admit that unless the situation is one which is created by your physical operations on the atomic system to realize, to manifest, to objectify the localization of the electron, then it won't be localized. It will have no properties at all, apart from what you do to it. Well, all of this is so extraordinarily radical, and so extraordinarily unlike Newtonian mechanics. But what does the physicist say? Even before the full answer was found, it was said, there is something going on here which limits classical ideas. They don't quite apply. But in any situation to which they do apply, we know they're right. And therefore, whatever laws hold in the atomic domain, they must merge into the laws of classical mechanics. There must be a one-to-one correspondence, an analogy there. Otherwise, in capturing some insight into this new domain, we'll throw out all we ever knew and throw out things that are true. This was called the correspondence principle, and a sample of how extreme this correction of the analogy, which has revolutionized everything, how extreme that is in a highly formalized science, one can give as follows. Every law of classical mechanics is true in atomic mechanics, that the velocity is proportional to the momentum, that the change with time of the momentum is proportional to the force, that the energy is conserved, all of these things, provided you will make one formal change, provided you will say that the momentum and the coordinate are not numbers, but are objects such that when you multiply the momentum by the coordinate and you multiply the coordinate by the momentum, you don't get the same answer. The difference between these two is an imaginary universal atomic constant. If you just write that one formula, then everything you had before is formally identical. Well, this is as powerful an illustration of the use of analogy and disanalogy in a formal science as I know. I'm going to have to come back to other aspects of this great development. Let me run rather more briefly over the three other examples. Radioactive nuclei, all of those practically that are made artificially and many natural ones, disintegrate by sending out electrons. We puzzled and puzzled over it, and it was quite clear there were no electrons in nuclei. So Fermi made the suggestion that one might describe this as one describes the emission of light or light quanta from atoms. Nobody would say there was a light quantum in an atom, but still we observe the light coming out. And he made a theory along these lines. It wasn't exactly right. The analogy was not quite perfect. But with a very little adjustment, which took 15 years of comparison with details of experiment, we got a theory that works fine. Yukawa, the Japanese scientist Yukawa, had a somewhat braver analogy, and its fortunes are still not entirely resolved. The way in which one describes the forces between charged bodies is, of course, that one charged body makes electric fields, and these electric fields are propagated to the other and give it some momentum and push it around. Nuclear forces, which are not electromagnetic and are very strong and spectacular, Yukawa said would probably be due to a field of a new kind. And replacing the electric field, there would be this new field. Replacing the light quanta, there would be new kinds of particles. And using the general arguments of relativity and complementarity, quantum theory, he concluded that because the forces between nucleons are of short range, these particles would have a mass of a couple of hundred times that of the electron, and from other particularities of the nuclear force drew conclusions about the nature of these particles. Well, they were found, they're called mesons, and the analogy which Yukawa started with has been refined. One has discovered that there are many differences between mesodynamics and electrodynamics. One is at the present point not quite sure what all of the key points of difference, of disanalogy are. Some of them have been discovered, but they appear to be rather the more trivial ones. But the theory as it stands now has predictive value. It's brought order and clarity to a part, anyway, of nuclear physics. It has kept people busy on 20 years, not surely of treason, but of a very, very odd kind of rarefied boondoggling. It has been a very major event in physics, and I don't know at the moment how to describe what limits this analogy, why it isn't a perfect one. If we were having a seminar on physics, I would talk an hour about it, but I still wouldn't know. It is probably, though, connected with my fifth example. It's true that these mesons were discovered, but not very long after that, and perhaps it will continue, I don't know. And in the last 5 years, one has found a whole lot of other objects, about 6 manifestly different and maybe more, which are also quite stable and last quite a while, and which are not simple mesons of the kind Yukawa envisaged. Almost certainly, their intervention in the picture, which is not something that is provided for in the analogy we started for, will provide a clue to the new point. But their existence raised a different problem, because whenever in physics one encounters a situation in which something doesn't happen or happens very slowly, one finds it interesting. And the great point was, why do these new particles not decay quickly? They do decay, but it takes them a terrible long time, and they come apart into products which one would expect to have emerge right away. Well, we have a great deal of experience with reactions that occur slowly. And a characteristic reason for that is that something doesn't want to change, like the energy of a system or the total charge. Something is conserved. And whenever that turns up, it also turns up that the fact that something is invariant is mathematically identical with the statement. The fact that something doesn't want to change is mathematically identical with the statement that something makes no difference to the system, either its position in space or some quite abstract idea like that. So the first thing that we all did was to try to find the characteristic of these new particles that didn't want to change. That has not been hard to do, and a most successful theory which accounts for some of the great peculiarities in this field has been developed, but we haven't a good name for what doesn't like to change, and the inventor of it calls it the strangeness. Well, these 5 examples are not at all meant to exhaust, but merely to illustrate the powerful use, the inevitable use of analogy in a well-developed, in a highly organized, highly formalized, and highly coherent science. And I need to point out that in every case, an immense amount of experience, of measurement, of observation has gone in both to the correction of the analogies and to their confirmation. When I turn to the question of analogies between sciences, I talk of something very different. There is, first of all, the fact that there are often things which are not analogies at all. There are congruences when in 2 different sciences, by different techniques, different language, different concepts, it turns out that the same subject has been explored from 2 sides. And when it turns out that there is a mapping of one description on the other, usually one description contains more elements than the other, is richer, the other may be more economical and more convenient. Examples, the chemical theory of valence and atomic physics, which are identical except that atomic physics does give an account of some phenomena, resonance and so, which were hard to cope with within the framework of the classical chemical theory. Another example, newer and perhaps not yet as well explored or understood, classical genetics on the one hand, and the discovery of the genetic substances, DNA and so, which are at the moment very close to being into a one-to-one correspondence, but with the certitude that the biochemical description is richer and has more dynamics in it and more subtlety in it. Well, it's not this that these are the great events of science, and when they happen in psychology, there is rejoicing, and when they don't happen, there is hope. These are the great events which bring coherence and order and large structure to the unfolding of scientific life. But probably between sciences of very different character, the direct formal analogies in their structure are not too likely to be helpful. Certainly what the pseudo-Newtonians did with sociology was a laughable affair, and similar things have been done with mechanical notions of how psychological phenomena are to be explained. I know that when physicists enter biology, their first ideas of how things work are indescribily naive and mechanical, and they are how things would work if the physicist were making them work, but not how they work in life. I know that when I hear the word field used in physics and in psychology, I have a nervousness that I can't entirely account for. And I think that especially when we compare subjects in which ideas of coding, of the transfer of information, or ideas of purpose are inherent and natural, with subjects in which these are not inherent and natural, the formal analogies have to be taken with very great caution. But for all of that, I would like to say something about what physics has to give back to common sense, that it seemed to have lost from it. Not because I am clear that these ideas are important tools in psychological research, but because it seems to me that the worst of all possible things would be if psychology were influenced in any way to model itself after a physics which isn't there anymore, which has been quite outdated. Now, one of the points, which is not the direct one. You see, we inherited at the beginning of this century a notion of the physical world as a causal one in which every event could be accounted for if we were ingenious, a world characterized by number, where everything interesting could be measured and quantified, a determinist world, a world in which there was no room for individuality, in which the object of study was simply there, and how you studied it was a matter of your job, but it didn't affect the object, it didn't affect the kind of description you gave of it, in which the objectifiability went far beyond merely our own agreement on what we meant by words and what we were talking about, in which objectifiability was something you could do irrespective of any attempt to study the system you were talking about. It was just the given real object, there it was, and there was nothing for you to worry about of an epistemological character. Well, this extremely rigid picture left out a great deal, and it's of common sense. And this is one of the things that I want just to wind up with, because the whole business of science doesn't just lie in getting into realms which are unfamiliar in normal experience. There's an enormous work of analyzing, of recognizing similarities and analogies, of getting a feel of the landscape, an enormous qualitative sense of family relations, of taxonomy. It's not always tactful to try to quantify. It isn't always clear that by measurement one has defined something very much worth measuring. It is true that for the Babylonians it was worth measuring, noting the first appearances of the moon because that had practical value. Their predictions, their prophesying, and their magic wouldn't work without it. And I know that many psychologists have the same kind of reason for wanting to measure. But it isn't, and it is a real property of the real world that you are measuring. But it is not necessarily the best way to advance the true understanding of what's going on. And I would make this very strong plea for pluralism in the kind of methods that in the necessarily early stages of sorting out an immensely vast experience may be fruitful and may be helpful, not for objectivity, that one has to agree on, and not for a quest for certitude which will never be quite adequately rewarded, but for the use of naturalistic methods, the use of descriptive methods. I have been immensely impressed by the work of one man who visited us last year at the Institute, and that's Jean Piaget. And when you look at it, really, his statistics consist of one or two cases. He has just a story, and yet I think he has added greatly to our understanding. It is not that I'm sure he's right, but he has given us something of which to inquire whether it is right. And I make this plea not to treat too harshly those who tell you a story having observed carefully, without having established that they are sure that the story is the whole story and the true story. But it is of course in that light that I look at the immense discipline of practice, that with all its pitfalls, with all the dangers that it gives to premature solutions, it does give an incredible amount of experience. Physics would not be where it is, psychology would not be where it is, if there were not a great many people willing to pay us for thinking and working. But now as to this point about what physics had taken out of common sense. I don't know whether these will prove helpful, but at least it loosens the resources that one can bring to any science. What are these ideas? Well, in our natural unschooled talk, and above all in unschooled talk about psychological problems, we have 5 or 6 things which we have got back into physics with complete rigor, with complete objectivity in the sense that we understand one another, with a complete lack of ambiguity, and with a perfectly phenomenal technical success. One of them is just this notion that the physical world is not completely determinate. There are predictions you can make about it, but they are statistical, and any event has in it the nature of a surprise, of a miracle, of something that you could not figure out. Predictive, but within limits, and ordered, but not completely causal. And another of these ideas is the limits on how much we can objectify without reference to what we are really talking about in an operational, practical sense. We can say the electron has a certain charge, and we do not have to argue as to whether we're looking at it to say that. It always does. We can't say it has a place or a movement. If we say that, we imply something about what we ourselves, I don't mean as people, but as physicists, are doing about it. And the third is very closely related to this, the inseparability of what we are studying and the means that are used to study it, the organic connection of the object with the observer. Again, the observer, not in this case as a human, but in psychology, sometimes as a human. And then, as logical consequences of this, the idea of totality or wholeness. Newtonian physics, classical science, was differential. Anything that went on, you could break up into fine points and look at. If you look at an atomic phenomenon between the beginning and the end won't be there. It'll be a different phenomenon. Every pair of observations, you know this, you predict that, is a global thing, and it cannot be broken down. And finally, every atomic event is individual. It is not in its essentials reproducible. Well, this is quite a pack of ideas that we always use: individuality, wholeness, the subtle relations of what is seen with how it is seen, the indeterminacy and the acausality of experience. And I would only say, if a poor and limited science like physics could take all these away for 3 centuries and then give them back in 10 years, we had better say that all ideas that occur in common sense are fair as starting points, not guaranteed to work, but perfectly valid as the material of the analogies with which we start. If any of this is true, there is another thing that physicists and psychologists have in common, and that is we are going to have quite a complicated life. The plea for a plural approach to exploration, the plea for a minimal definition of objectivity that I have made, means that we are going to learn a terrible lot. There are going to be many different ways of talking about things. The range from almost ununderstood practice to recondite and abstract thought is going to be enormous. It means there are going to have to be a lot of psychologists, as there are getting to be a lot of physicists. When we work alone, trying to get something straight, it is right that we be lonely. And I think in the really decisive thoughts that advance the science, loneliness is an essential part. When we're trying to do something practical, it's nice to have an excess of talent, to have more sailors than are needed to sail the ship and more cooks than are needed to cook the meal. And the reason is that in this way, a certain elegance, a certain proper weighing of alternatives guides the execution of the practical task. It was that way during the war on many things, and it's, I know, a luxury that we all want. We are all, for all kinds of reasons, worrying about how our scientific community is to be nourished, and enough people who are good enough come and work with us. And then on the other side, we're worried about how we're to continue to understand one another and not get totally frustrated by the complexity and immensity of our enterprises. I think there are good reasons of an inherent kind, as I've said, beside the competitive reasons with the communist world, why we would do well to have more and better scientists. I know that exhortation, money, patronage will do something about this. But I don't think that's all. I think that if we are to have some success, it must be because, as a part of our culture, as something that is generally understood, the understanding, the life of the mind, the life of science, is something which in itself, as an end, as well as a means, is appreciated, is enjoyed, and is savored. I think that has to be a very much wider thing in the community as a whole, before we will enjoy with the community as a whole the healthy relations without which the developing powers of scientific understanding, prediction, and control are really monstrous dangers. It may not be so simple, this having in the community at large some genuine experience of the pleasures of understanding and discovery. It may not be simple because beyond that, what this requires is not merely that this is agreeable, but that it has a kind of virtue, and that not only the consideration of ends, products and accomplishments and status, but the texture of life and its momentary beauty and its nobility are worth paying some attention to, and that among the things that contribute to that are the life of the mind and the life of science. Let's try.
The program you've just heard was produced by KPFA, the listener-sponsored station in
I want to thank you for the warm welcome, and Dr. Mackay for his warm and generous words. A few years ago, an institution of learning, not far from here, but not in Princeton, inaugurated a new president. He was not given to eloquence, and he made an inaugural address which was not very distinguished. But in it there was a passage which struck the hearers as rather moving and appropriate. That unfailing arbiter of our morality, the New Yorker, not long afterward, ran the relevant section of the address, along with an address that had been given a few years earlier, also by the president of an institution of higher learning, also in this neighborhood, also not in Princeton. And the two were remarkably the same. Only a few cunning changes of word had been made. Whereupon the earlier speaker received from the later speaker a telegram saying, "It seems that we are both in trouble." I think, notwithstanding Socrates and notwithstanding Erasmus, if you, whose primary concern is salvation, and I, whose primary concern is acquiring new knowledge and at least transmitting old, are talking to each other, it is because we are both in trouble. I think one sees many signs of this. I think it is not an accident that the late Pope Pius spoke and wrote on many occasions of the most recent findings, primarily in physics and astronomy. I think it is not an accident that my associates have talked with an almost evangelical tone as they called on their colleagues and on all men who would listen to put an end to those institutions which they themselves had helped make insupportable to war and the things that make for it. I don't think the troubles lie primarily, the troubles that bring us together, lie primarily in science itself, defined broadly as to scope, but reasonably narrowly as to its intention, which is to learn and order, to find out new things and to find the order of things, rerum cognoscere causas, in a primitive phraseology which cannot be improved on. I think if I were talking to professional scientists or listening to them, we would have a great deal to say about the threats to the vigor and the beauty of science. But I have also to report that these threats at present have in many parts of the world, and here at home and in Europe, not impeded the most striking and wonderful advances and the most cordial welcome of these advances by those who are capable of appreciating them. The troubles that bring us together have perhaps rather to do with the fact that the very development of scientific knowledge has had consequences, has changed the world in a way which could not have been fully anticipated, for which we as a group of men and women have never been fully prepared, and which present us with questions and with difficulties for which we look in vain to our tradition for an answer. I do not mean that the tradition is useless, but I mean that is on these things silent. Now, I'm not tonight, first of all, I'm not going to cover the waterfront, because an hour is not only not enough to introduce you to the marvels of science, which Dr. Mackay promised, it is not even enough to tell you about the trouble science has brought. I'm going only to talk about a few points, and they are not perhaps the ones that come first to your mind. With these, I am also not going to try to give a prescription, though at the end I will get provincial and tell you what a physicist who has lived through the years of my youth, what special points he is likely to bring to bear on these troubles, or at least how it seems to me. I'm not going to give a prescription, but really to do what I can to help myself, and I hope you, understand a little better what the situation is, to face up to it. And perhaps that is the first step. One can tell a little bit about it if one thinks back to the time 170 years ago when this country was being created, being founded, and to the Enlightenment generally, and to the liberal hope which animated such a large proportion of the great men of the 18th century. I need not remind you that they were aware and spoke of the contribution of an increased understanding of nature and a growing understanding of man to the material civility of society. I need not remind you that they prized as sensitive, gentle, and cultivated people of wide interests, human curiosity, and our desire to understand things as good in themselves and requiring no complex justification in terms of other ends. But they certainly had in mind also that there would be beneficial effects of increased knowledge and understanding in the functioning of man as a man. The repeated references to doing away with superstition, the repeated references to the horrors of past error, past illusion. They thought, for one thing, and this has certainly turned out to be true, that with increasing skill and increasing knowledge, and one need not be too sticky about the distinction between them, men would have wider choices. They would be more in command of what they did and did not do, and so would be more fully human. They thought that with a better understanding of the connection of things, men would have a more informed basis for making their choices, that their decisions would be based on a better knowledge of the consequences of what they did or opted. And they thought that man would have, and this equivocation is one I will have to come back to, a far more pervasive and ennobling understanding of the elements of necessity and of order in the natural world. They would understand the reason for things. Now, in vast measure, all of this has been true, and true really beyond anything that could have been expected 200 or 100 years ago. I don't want to even stress the material side of it, except insofar as it is relevant to some of the problems to which I will return. But knowledge of nature, and to a very small extent of man as man, and to a very large extent as man as animal, coupled with an always available human cupidity, with a reasonable amount of human labor, occasionally with a certain amount of public spirit, rather more frequently than one might expect, and with luck, has certainly altered the kind of material world we live in, and has in fact made a lot of choices available which couldn't have been available 100 years ago, many of them of a trivial kind as to the choices of food or clothing, many of them a little less trivial as to the choices of work or habitation. In fact, one could almost say that the multiplication of wealth has paralleled in some way the multiplication of knowledge, and that there is a kind of strange parallel between the progress of knowledge, which has been very great indeed, and progress in, well, let us say the national wealth or the world's wealth, measured in any way that you want. But these high hopes for the relation of man himself to his knowledge and his environment have, I think, not been nearly as well fulfilled. And from everyone you hear that the progress in knowledge has not been matched by a progress in wisdom, by a progress in humanity, by a progress in virtue. I am not sure that it is possible to progress in virtue. I am not sure that the supreme examples of that do not lie in the past. But there is in any case a sense of disharmony and unbalance between those things which have followed a curve, and the two curves are not the same, but it's not a terribly important point, a rapidly rising curve, the amount we know and the amount we have. There's been a mismatch between those things and any sense that we are up to it. I want to mention 4 points at which it seems to me things have gone wrong in the sphere of the human understanding. I'm not going to talk at length. Well, I hope I won't talk at length, but I will not talk in detail except about 2 of them. One is that everything has gotten enormously bigger. This is partly, of course, because there are more people. It is partly because the units of human activity have gotten bigger. It is partly because of the pervasive, almost instantaneous nature of something that one could call communication. It is not, in all senses, properly called communication. When we just observe ourselves, we notice that our ability to deal with people is one thing when there are very few, and that it rapidly changes when we have larger groups. And this can be studied and has been studied. And as soon as you go beyond a very small number of people, you no longer have the sense of their integrity as a person, and instead you are forced to create a kind of abstract stereotype, a party, a position, a leader, just in order to be able to cope with it. You can imagine what that amounts to in a world with 2.5 billion people. As a almost inevitable consequence of this, but also as a peculiarity of the way we run our affairs, the notion of choice, never a simple one, the notion of deciding something, which is really one of the basic traits of being a man, and perhaps that function where one is most concerned with his integrity. This whole area of responsibility has become extremely befogged and clouded. We talk to each other about our responsibilities and our duties, and in simple situations, the family, parts of the community, we recognize them, we try to live up to them. But our duty to the larger units, to mankind and so on, these are indeed very foggy notions. And I think much of the anguish talk about how we are to live in the new situation, how we are to avoid the dangers and reap the benefits, how we are to retain a kind of kindness and not all kill each other. Much of the futile, rasping, horrid quality of this talk is because no one really has any sense of what does devolve on him, what he can as a person do. There is a frightful disproportion between our willingness to undertake a true or a secular martyrdom and our ability to find any way at all in which to do it. Simone Weil wrote, and this was 20 years ago, that in comparison and contrast to all the earlier generations, hers was marked by the paucity of true responsibilities and the proliferation of imaginary ones. She went on to say, this circumstance, once fully appreciated, conduces to a marvelous serenity of the spirit. But then she was not interested. That is not right to say. She despaired of social betterment. She was interested, and she died of this interest. The third of the things that has not gone right, and which interferes in a cruel and, to me, heartbreaking way, both with the ability of men to understand the elements of necessity and order in the world about them, and in a way which is not so necessary, but which is still quite troublesome, with the wisdom with which they can make decisions and choices, has to do with the almost total collapse of valid communication. This is a subject I want to talk about. And the other thing, which I will talk about a little, though perhaps in a more personal way, is that the old theme, the eternal theme of the harmonization of the necessary, that is, that which follows from the laws of nature, that which cannot be otherwise, and the good, that between necessity and freedom, that between efficient cause and purpose or final cause. This joint has suffered from the accretion of a terrible lot of calcareous matter. This joint is inflamed and in bad shape. And to this has to be added that in this matter I use a word that bothers me a lot, but I use it because I think it is something we all understand. In this matter of values, that is, of the act of cherishing, dedicating, and committing, there is an enormous role played by tradition, and that, if nothing else, the world we live in is a world in which change is so great that tradition is emptied of much of its content. Emptied not because the tradition is not solid, but emptied because, as I said earlier, it has nothing in it to correspond to the questions, the problems, and the realities which erupt, partly because we know more, partly because we do more, partly because we act differently. Well, of these last two, I will say, to these last two, I will devote this talk. They are not the only important ones. I think the problem of what happens to societies when they become effectively large, what happens to societies when there is a dilution and a diffusion of responsibility, are of the utmost gravity. But you have a whole series of lectures, and I hope that some of your other lecturers will have a sense of competence to talk about these things. I don't. I don't have much sense of competence about any of them, but I have some very serious and sober worries about the problems of communication. I don't think here either that the world is such that one can solve the problems that I am going to talk about. I don't think here either that one will go back to a situation in which communication was a better thing or served other purposes. But I think that it's important to know and important to bring to the real world an attitude which does it justice. And I want to mention 4 separate aspects of the growth of knowledge, well, of the nature of knowledge, which seem to me to contribute to the difficulty, or to define it. The first is a brutal semi-quantitative thing. And it has to do with the very success of the scientific enterprise. Include in this as much of the study of man and his records as you will. I mean it very broadly. Include in it the study, the design, the work on instruments whose purpose is to get further information. Take it as broadly as you want. The growth of knowledge can, of course, only be measured. The sum of human knowledge can only be measured in rather unsatisfactory ways. It doesn't refer at all to the quality of the individual work, whether that be measured in terms of what it must have taken in the greatness of the author, of the composer, or what it will mean in bringing insight and order to the life of those who read in later years. I don't think that one can talk about the sum of human knowledge in terms in which the Oedipus or the Gospel of St. Matthew play any relevant part. So I'm using it really in the sense that ordinary people would ordinarily use what people have found out about the world, including, when they can, it's not very much, our human part in it. Found out about it in a way which they can tell each other, found out about it in a way which, with enough trouble, can be verified and established as reasonably right or altogether wrong, found out about it in a way which causes them to write papers about it and fill journals about it and make books about it. Well, you can measure this either by volume of publication or by the number of qualified and trained people who are working at it. Neither measurement is entirely happy-making, but it is really so that no professional man will allow the accumulated publication in his field to hold trivial matter. It's hard enough without that. And the volume of publication is a good measure, not of the depth or beauty of new knowledge, but of its bulk. And the number of people, well, of course, today not everybody is likely to be as smart as the people who were working, let's say, at astronomy 200 years ago. On the other hand, they have enormous advantages in a much more effective collaboration and enormously better instruments and enormously better methods of analysis. I mean by better, not more beautiful for the time, but benefiting from all that has come before. And it is this cumulative quality to knowledge, this quality that everything you learn, if it's any good, is not only the end of a trail, but the beginning of a new trail. Everything you learn is not only an end in itself, but an instrument for acquiring new knowledge that has given rise to this elementary, extraordinary, and terrible fact that our knowledge has doubled practically every 10 or so years for a long, long time, for about 2 centuries. One can talk about the future, and it is important to bear in mind that this rate of increase can probably not be maintained very long for the obvious reason that not everybody can be engaged primarily in getting new knowledge, and some people have to do other things. But it does mean that the world we have lived in the last years is probably going to get worse. It's not going to get better from the point of view of the rate at which new things are found out and partially ordered and understood. This alone means that not only is the furniture in our house changing from generation to generation and in less than a generation, but the means by which we could hope to understand it are changing. And it means that schooling can never really hope to keep up with any reasonable proportion of the sum of human knowledge. It means that we who are not any longer in youth will be very lucky indeed to know in 1 or 2 fields what is really known, what has been found out. Many will not know that. Most people won't. Most people will be terribly out of touch with human knowledge at its growing tip. Now, there are many illusions on this subject. And I think we foster them in our schooling. They are, among others, the illusion that the elementary truths that were found first in the history of the sciences are in a certain sense, the basic ones, the ones which encompass what came later. And that therefore it is enough to have a brief synoptic schooling in some of the branches of science, and then one will have a sense of what it's all about, and the rest is technical detail. This is not so. In the first place, it's not so on the practical side, which I regard as very, very unimportant. That is, the things which turn out to be decisive in the management of human affairs are not likely to be things that one learned about in school. They are likely to come from rather recent findings in science. But I don't think that that's a major point. the fact that we're burning so much organic matter, that the polar ice cap is going to melt much faster than it otherwise would, and that New York will be underwater, this is an elementary kind of thing to explain. If it's true at all, it can be explained. It may not be true at all. It's not hard to understand. The fact that there are dangers in blowing up 100,000 large bombs is true and can be explained and should be explained. And you don't have to go to any kind of school to learn the difficult ideas that are involved in that. That's not what I have in mind. The point is that as one goes on in scientific things, it is precisely the basic things that get changed. It is precisely the basic things from which you could in fact deduce a great deal else, which do have this organizing power, which are primary, from which something follows, which are the origin or the formulation of necessity. It is precisely in these that great changes take place. And these are the last that we can explain to each other. These are the last things that it is easy to tell a layman or another specialist about. So that the loss is precisely in that great field of understanding of necessity and order. The structure of the sciences is that they come from a common matrix. It is also that they have a wonderful freedom from contradiction. It is also so that they have a quality that you can never be confident that any part of any of them is irrelevant to any other. They have a potential relevance, but they are not in any way reducible one to the other. They are not in any way deducible from any first principles, and certainly not from any first principles which can be made generally a part of our culture. And so it is that although the process of ordering, that means of recognizing the particular in the more general, although this process goes on at a great rate and simplifies instruction in science and simplifies its understanding and makes it possible for people with only a finite number of years in school actually to get to the point where they can find something new, it does not keep up with the ever-branching, growing novelty of the subject. This means that all of this growth and wonder is almost unavailable to man in general, and that it is typically available in small, specialized parts to rather small, specialized groups. Groups which, it is true, stretch from land to land. Groups which feel across the physical frontiers and across the barriers of political and doctrinal hostility the greatest gratitude and welcoming each of what the other does. But still, small groups in marginal communication with each other and in marginal communication with us, with man at large. These are two great imbalances to which I would like to add a third and perhaps a fourth argument. The third argument has to do with an old truth that has been newly refined and illustrated both in studies of perception and thinking and in the experience of atomic physics. It is in a certain sense trivial, but not so trivial. It is that there is an element of action in any intellectual activity, even so marginal a one as perception. There's an element of action which means that no perception is possible which does not leave out, which does not lose all record of a great deal that was going on. This, I think, wise men have always known. We have always known that our tradition and our history made us, made what we could understand and could see, blinded us to some things. We have always known that whatever else they do, and it's a great deal, the arts help to enable us to see what without them we would be blind to, and to see in common, not just as a private vision. In a certain sense, this is trivial, but it is not so trivial. I don't know whether to tell you a story that I like. It's a story of one experiment, one set of experiments that Rostand did in Paris. Has to do with nothing more elevated than a dog and nothing more important than the signals sent along the acoustic nerve from the ear to the acoustic cortex. And what it is this. If you repeat a certain sound, a bell ringing, I think it usually is, you see, if you measure the currents coming along the main fibers of this nerve, you see a pattern, and this pattern is reproduced and tells you that there is some connection between the bell that rang, what happened in the ear, and what will go on in the dog's cortex. But if you put a piece of meat in front of his nose and ring the same bell, there is no signal there at all. This is only to go one step further back. Not even in the sense organs, there is a kind of organization, pre-organization of what it is that you will learn, of what it is that you will notice, of what it is that will be part of the structure of knowledge. This, of course, I like, partly because we have listened to these learned folk, mostly in England, talk about the primitive thing, the primary thing on which all certainty was to be based, and that is a sense datum. And when you look at it, you see that it's a most elaborate and subtle and beautiful artifact and not primitive at all. But I like it also because it illustrates in a kind of pre-cognitive way that the cost of knowledge is a great deal of ignorance. The cost of perception is a great deal of imperceptiveness. That in this whole field, one has to adopt the view that the potential is infinitely larger than the real. One has to adopt the view that without tradition, we would know nothing, but with tradition, we have also lost a great deal of our knowledge, of our possible knowledge. This sense of the infinity of what there is to know, of the partially accidental quality, or rather let me say historical quality, it may be a wiser word, of what we do in fact know. This is the third thing which takes apart the common understanding based on effective communication between people about common experiences in terms which are defined by those common experiences. The fourth is related to this, and that is that I believe it is a very accidental thing too, and again I would say it must be studied by historians and not by logicians, as to what effect, if any, developments in science have on human life. Now, I mean that not primarily in terms of the mechanical differences, although here too it seems to me that there have been some mighty odd accidents. Things could have been done with scientific knowledge, which lay fallow for a long time because they didn't have any great sex appeal for the economy or the industry of the time. And things get done in a great hurry, like making atomic bombs almost before you knew how, because they do have a great sex appeal. And a good deal could be written about the randomness and lack of logic in the relation between what we learn how to do and what we in fact do. But that's not what I meant. I meant that as really great discoveries are made in science, they may or they may not find in the ideas of the age a real resonance. They may or they may not affect the way people think about the problems of their own life, about what is in the vulgar sense called their philosophy, how they look at problems. I think those who have studied the history of science tend to agree that picking up an idea that has been found in the specialized sciences and seeing in it some clue to the meaning of life or the attitude toward truth or the way to conduct oneself, that this is something that cannot by any means be counted on. It sometimes happens and it sometimes doesn't. It tends to happen primarily when the discovery, though important, is rather primitive, so that it can be formulated in terms of unspecialized experience. It tends to be very unsatisfactory when the discovery, like relativity, is rather far along in a science, so that you cannot even tell an ordinary man what it's really about without making him really sit down and listen for several years, at least for several months. But it depends not only on that, it depends on whether the word that is used to mark the discovery happens to excite a mood or a sentiment or a hope in the community, in the people who are thinking in the community at that time. So you find the Enlightenment very much more excited by Newtonianism than Newton ever was. Newton could not have adopted the views which his discoveries were supposed to support. And today, there are relatively few things that are found out about the world of nature which are properly understood and which affect man's view of the world or of his place in it or of the way he should conduct himself. These 4 points, and there may be others, mean that we face a wholly new problem in living with one another. I will say a word or two about how I myself have come to look at it at the very end, but it must be obvious that if my description is in any sense faithful, and it's exaggerated because I've left out the mediation of textbooks, I've left out the mediation of popular journals and all the rest of it, but I have done this deliberately, thinking that this mediation does not solve the problem. If it is in any way a true description, then the consequences for our ideas of education, our ideas of a community, and many of our political ideas are indeed not trivial. Now, I think I will say a few words about a more provincial subject, almost in contradiction to what I have just said. And that is something of what the atomic physics of the early years of this century has predisposed those who lived through it to look for, what view it has given them. Because this is relevant to my own view of the question of the necessary and the good. It is relevant to my own view of the relation, well, of the tangled and, I believe, usually very poorly discussed subject of the relation between science and good, or science and value. There are a lot of trivial things to be said, which show, if nothing else, that the phrase, the ethical neutrality of science, must be a fairly empty one. As an occupation, it itself is based on a very clear belief that it is good to know, and that general knowledge, which encompasses particular knowledge, is better than particular knowledge. There are affirmatives and affirmations of value at the very beginning and in every exercise of the scientific life. And it is equally true that both by changes in institutions and by changes in knowledge, almost every ethical question of any complexity that man has ever faced has been altered by the development of science. I even believe that the question of one's attitude toward war, which is dealt with in so deep and apparently conclusive a way in the Bhagavad Gita, would not today be dealt with in the same way by the descendants of the authors of the Bhagavad Gita. And certainly it is impossible not to learn a great deal that is quasi-evaluative from science, in the very sense that Socrates and Plato used it. You learn that things are good conductors, people are good conversationalists, but only because you have a prior good already defined. It comes out in the end, for all that you say, that the good is neither in conflict, nor excluded from, nor disconnected from science. They intersect, they are involved with one another. But the good is complementary to science. And now I have used the word which makes me go for a moment into the experience of atomic physicists. This is not the experience of having lived through the last 15 lurid years, but a much earlier one, a purely intellectual one, a purely cognitive one. It was the discovery of the laws of atomic physics and an understanding of what they mean. It is a theme, an experience that has been talked about also here in Princeton very often by Niels Bohr. I think he has written best about it. I have talked and written about it for wider audiences, I think with a total lack of success, but I can't entirely help telling you about it. In trying to understand not what a nucleus is or any such novel trash as that, but just what makes the properties of the atoms of chemistry and the normal physics of human life, where we don't break up nuclei all the time, but we do look at color and experience hardness and so on, came upon the fact that the notion of force, as we learned it from Newton, and of potential energy, were applicable to a very considerable extent in these problems, as they are not applicable in the contemporary problems of the constitution of matter. But that the notion of motion and of laws of motion, as we learned them from Newtonian mechanics, or of wave motion, as one learned in the case of light and other things, that these things were not at all simply applicable to the atomic domain. And when it got finally unscrambled, it turned out that although all earlier physical experience had some relevance to the description of atomic systems, it couldn't all be used at once. But more or less, speaking in a very qualitative way, half of it could be used at once. The most famous example is the description of things as being somewhere and sometime, a space-time account of them, saying where they are when. This is a perfectly useful and valid way to talk about some atomic phenomena, but not all. There are important experimental situations in which the where and when cannot be talked about without logical contradiction. Talking about the great laws of conservation, of energy and momentum, impulse. These also are laws which can often be applied, but not always, and never when you can say where and when. That is, never with any kind of precision, never on an atomic scale. And this situation, that we had an apparatus of conceptual machinery talking about nature, and that parts of it, that all of it was useful, but parts of it were useful only in situations in which other parts had to be excluded. This was called by Bohr complementarity. He has made a great deal of it, and I think all of us who have lived through this have. Let me give you one example. In the old days, especially, let us say, in the height of Newtonian mechanism, there were different orders of nature with an almost vertiginous difficulty about thinking how one might reconcile them. The order of the entirely mechanical and the order of the entirely purposeful. The conflict between efficient and final cause. A great breach, it seems to me, and it was really a breach, the importance of which was fully understood at the time, was made just by the great doctrine of the evolution of species, a doctrine which even today is not riveted firm. There are really quite open questions as to how one gets from here to there and what is involved in it. But at least it provided one element connecting the notion of fit or suitable or good for with some kind of machinery. This has been brought a great deal further by another arch, which is also not riveted closed, and which has to do with our confidence that living material can be created from dead, and that we know even the conditions under which this can be done and the conditions under which it probably did occur. It has been still further brought forward by another arch of a very different kind, in which it has been recognized that the gene is itself a physical, a material symbol. It has in it the information which will produce the baby or the flower. It stands for the baby or the flower, and it implants with the flower and with the matured baby the power to transmit this information, usually with a few uncorrected misprints, to the next generation. Well, in every one of these, you see, the closing of a great arch in which one realizes that there is no sharp separation between those phenomena that can be talked about in terms of efficient cause, and those phenomena, like all of life, which should be talked about also in terms of purpose. You cannot describe an organism without saying what its organs are for. You can, but you find that you make a long speech without saying anything useful. One finds throughout the whole arch, from the furthest that we can see with our telescopes and the earliest that we can see and conjecture, to very close to the threshold of those concerns which are primarily yours, man and his freedom, that it is not entirely or primarily a difference in what is being talked about, whether one talks of it as necessary or as free, but primarily in terms of what one is talking about it for, primarily in terms of what kind of use one wants to make of the conversation. Well, this is one lesson which those of us who lived through these earlier years are not likely to forget. And it goes along with another lesson. We have seen very deep changes in what were thought to be almost unalterable ideas about space, time, causality, necessity, a good swatch of Kant's categories. We've seen that these changes came about not because the old ideas were wrong, but because they were adapted to man's common experience, the experience which we had all had together. And that as soon as the inventions of technology and the logic of mathematics are brought to bear on the world to look at something that's never been seen before, you may expect also some great surprises, not merely in what you find, but in what you can do in the way of talking about it. What ideas are valid and what ideas are full of an inherent contradiction. This notion that general ideas are likely to be limited to and rooted in experience and in tradition, this tendency to say, how did you learn that? What do you mean by it? This is certainly a second great consequence of living through this time. Because in the past, traditional ideas, for all the enormous sense of change that human history gives, have in these abstract matters not altered so often or so rapidly. They have. They did in the 16th century, in the 17th century. And I think we probably understand that they may have also in Hellenistic times. But we in this time have seen a tradition in one science remade before our eyes, and it gives us, toward tradition, a special blend of veneration, because without it nothing could have been done, and a little critical skepticism as to its necessity. We fit this in with the fact that knowledge can be true or false, but true knowledge is in the fact that we have true knowledge of this and not of that is in a certain sense an accident. Now, I have tried sometimes to say how one can try to live with this, and there's a great deal more to say than I have given a basis for, and what I have talked about I can't properly polish off with any simple word. But it does seem to me that with the vastness of the intellectual scene, with the vastness of the human scene, unparalleled in man's history, with the lack of unique and engirding order, the existence of great deal of local order, with the nostalgia which this situation is bound to produce in anyone who faces it with honesty, with some appreciation of what tradition means and of its mutability and perishability. We have a kind of mixed, double, cross purposes, obligation and duty. I think we have to cherish, build, and love our own tradition, our own work, what is close to us, what we can really live in. I think we have to have a kind of open, warm, welcoming interest and love for other people, for other people's work and their tradition and their cherishing. I think this is very hard. And really, if it were not that we could help one another, not least by appreciating how difficult it is, it would perhaps not be possible. I think it is a condition for being a man in this mid-20th century.
Dr. Oppenheimer has very graciously consented to wait on a while to answer questions. Now, this is a quite unusual opportunity for us to formulate our questions and our concerns and to listen to the answers of a master who, when he is involved in mystery, will admit it. Now, I'm going to insist, I feel I ought, that the questions be in writing. Those who feel moved to pose them can receive paper, if they don't have it, from the ushers. If you hold up your hand and don't have paper, you will get it. If you kindly bring up any questions that you may have, can I bring it up here? Because if you make the question from there, nobody will hear. And it's important for the others that, yes.
I once gave a lecture on physics, and at the end, either I or the chairman said that I would be glad to answer any questions. Someone said, "Would you please say it over again?"
Yes. Where does the first come from? Or have all the questions been answered? Here comes a question. Theological in nature for a scientist. What is your concept of God? Scientist.
I do not use the word. It seems to me the most ambiguous word I know.
The second question, is our predicament due to the fact that with, I'm sorry, that with an unlimited universe, we demand unlimited freedom. We demand unlimited freedom. Let's repeat. Is our predicament due to the fact that with an unlimited universe, we demand unlimited freedom?
Mine isn't. I don't understand this. Does anyone know whether the universe is or isn't limited? Would anyone really be able to make a case for this? I think it's a very open question, and it seems to me quite irrelevant to the human predicament. I know of no one who demands unlimited freedom. I think the most anyone demands, with a good conscience, is to know what he's doing and why. And I think this is hard enough. If I don't, let me take it.
Yes, yes, sir, all right.
Maybe we... In what sense does the scientist depend on the laws of nature that you mentioned? Well, I'm afraid I don't fully understand. If the laws of nature were different, presumably there would be nothing like us. I don't know whether you mean, do we, for our existence as humans and people who get curious about things, depend on laws of nature? Of course we do, on much else beside. But of course, you always use what you know in order to find out new things. You use it in order to build instruments. You use it in order to interpret your findings. You use it instrumentally in every way. And that is why you cannot just say to a young fellow, no matter how bright he is, no matter how gifted, and no matter how industrious, you can't say to him, now look, you find out the answer to the question, how many different particles are there in the world? Because the whole business, what is a particle, what we mean by such words, and how we go about doing it, is completely built on generation after generation, century of accumulated knowledge of the regularities of nature. I don't know who asked this question, and therefore I can't guess whether I answered it. Would the asker say whether that was it? Well, that's what...
Yes. No, this was...
No.
2 hours.
No. A great deal has been written recently about the possibility of the integration of knowledge. Will you comment, as a scientist, on the possibility of such integration? Yes, I will. In fact, I have. Cross-connections between one part of knowledge and another do exist and can be very fruitful. For instance, I think most of the laws of chemistry and much of its lore are translatable or from physics, derivable from physics in principle, but they are quite separate sciences. I don't believe that from the integration you will get very much, because if you take only what is common, let us say, to psychology, geophysics, and cosmology, just to take 3 sciences at random, it will be the principle of sufficient reason, and we are even not so sure that the principle of sufficient reason is true. That is, as you get more abstract, which is what I conceive it integration must mean, less and less follows from what you say. It may have a wider domain of applicability, but you can deduce very little from it. Integration takes place. It's taking place all the time, but it is local integration. I'm not trying to make a bad political joke. It is local integration between parts of one science and another, parts of the same science, integration by which one understands that two things are special cases of the same regularity. But integration in the sense that it would help rather than complicate the problem of learning, I think is less likely. I have another one. I'm behind schedule. Since the quest for knowledge is not restricted to any one nation, should not all new discoveries be disseminated throughout the world scientific community? Well, this is a question which the answer is obviously yes. On the other hand, if you are talking not of a new discovery, but of a piece of deadly hardware, you're talking of something outside the domain of science. And I think you can make arguments that we should tell our enemies how to make deadly hardware too, but they're arguments of a wholly different order from that we should tell them what we find out about nature and about life. And I hope that you meant the former. This is almost true, although there have been periods when it wasn't true. It is, as far as I know, almost true today, in spite of the deadliness of the political conflict. And it has not been true only to a very much more minor extent than people have believed if you refer to the truths of science, if you do not refer to technological gimmickry and the necessary design details. It's much more nearly in order than most people think. But here again, if you mean anything other than the discoveries of science, I think the question can be answered, but not within this framework, and I would have to know much more what you did mean. Did we understand you correctly in a statement which was, in essence, all ethics are subject to change as science changes? No, you didn't hear it, at least. I said that ethics was affected by science. Its content is affected by science. I mean this not in terms of precepts, but in terms of what the precepts mean. It is very clear that the concept "thou shalt not kill" has been complicated in recent years. Do you believe that knowledge can be accumulated indefinitely? Does there appear to be an end, a final scientific theory? I think that it will continue indefinitely, but I think that this is, on the one hand, really a question of whether we will be able to think of new things to learn, and on the other hand, of whether we will be so organized as to wish to do it and be able to do it. As to the latter, the times in the past when there has been a real regression in intellectual activity, and scientific life is a large part of it today, have been very different than what seems likely today, barring really very grave disasters. I think it could happen if the much talked of Third Great War were to occur, and I think it could happen if an all-embracing and a fanatical political tyranny were to, a political tyranny with ideological or religious fanaticism were to get an absolute control of the world. That these are pretty extreme things. As to the question whether living more or less as we do now, only more so, we will think of new things to find out, I'm fairly confident we will, and I'm fairly confident that the arguments for doing it will be the same curiosity, interest in understanding, and the self-promoting dynamism of knowledge, that once having settled one question, you're then in such a much better position to ask a lot more. I think this will go on, and at a rate which will be greater than we have witnessed yet, but perhaps not 100 times greater. Have I caught up?
I think so. I just do you one by one.
What significance, if any, do you think that the Darwinian theory of evolution has for morality? I think I would answer that rather simply, none. I think those elements in morality that would be affected by the Darwinian theory were in trouble without it. Do you feel or believe that there is a mystical side to man's life and his relations to nature? Yes. It is impossible to doubt. I think it may be a little bit a question of words, whether you have in mind John of the Cross or just some rather unformulated sentiment. But I don't doubt either. I certainly don't doubt the latter, and I don't doubt John of the Cross at all. Do you feel that the present expanding universe can be related to an initial cause? I'm afraid I'm going to have to leave that to the late Pope Pius. The trouble with this one is that I can't make it out. If I could, I don't think I could answer it. Do you put the religious philosophies of the world's religions in the category of change and evolvement? Well, I would think that an historian would be more likely to answer that wisely than I, but it seems to me manifest that the answer is yes. In part, anyway, yes. And what part does your comment of lore play? I must be reading this wrong. In relation to the progress of science in recent discoveries of the nuclear age. Don't make that up. Our knowledge is limited, but we have to decide, and some decisions will be very definite. What has to be the measure for our decision? I think the decision should be virtuous. I don't think you can make a general statement any less thin and tautological than that. You're talking about all of human conduct. Most of it actually not categorized or covered by any rule, even if you were willing to accept a rule. I believe you mentioned life coming from dead material. What do you mean? Well, there is a very well-known Soviet Russian biochemist called Oparin, and he conjectured quite a long time ago, before the last war, that if one had a reducing atmosphere, ammonia, methane, such as is generally believed to have existed on Earth in the early days, and if there were any kind of electrical disturbance, spark, or ultraviolet light, you would build up organic material. And this has been verified in the laboratories of this country, not in the sense that a living organism walked out of the experiment, but in the sense that very highly developed polypeptids were observed, and precursors of proteins, and in some cases even proteins themselves. In other words, precisely the kind of object of which we know that if it's made right, it will survive, reproduce, and multiply. This is, I said, this was not a well-riveted piece of knowledge, and I don't want to leave you with the impression that I know for sure that this will come out, but I think it's important not that we know this, but that it's a kind of knowledge which we've begun to think of as possible. Will you comment on the freedom of communication among scientists in the U.S. government today? I am sorry, it's 5 years since I've known anything about it. Do you feel that the concepts of physics can be validly applied to the field of social work, i.e., the acausal world in quantum physics, something, the free will of man? No. I will not say that no concepts in physics will be without analogy in, well, what should we say, psychology. The analogies will probably be pretty bad, and it will probably be better, probably come out better, if the sciences learn their own vocabulary from their own experience. When something is starting, of course, it's new, and you can do no other than to borrow from a familiar experience in an attempt to describe it. That almost certainly will get you into difficulties as soon as you begin to find out what it's really like. As that goes on, your terminology has to be refined. Maybe you invent new words, maybe you redefine old ones. If you redefine old ones, you're in effect making the basis of a large number of bad puns. This has happened, and I have no doubt that in psychology some of the ideas of physics will occur, but indeterminacy in physics and free will in man are not related phenomena. Well, here are two difficult questions. One is, what is truth? And the other is, what is reality? I will answer the second question as I did the question about God. It is a word I do not use, and for much the same reason. It says, how does the scientist conclude that he has the truth? Well, I think the whole of science is a giant machine for finding out that you've made a mistake. And if the machine fails to find for you, the machine being all your colleagues, all other people working in the field, and their tight logical implications of one consequence from another. And if an ardent effort to prove that you are wrong doesn't work, then either what you said was more or less true, or it wasn't anything at all. And we think that we can tell the difference, because if it wasn't anything at all, nobody tried to prove it was wrong. Nothing happened. So it is, and I don't mean to be frivolous, but the point really is that science is not troubled by these questions, and that's one of its strengths. Whether one can learn from this how other uses of the word true could be refined is a much more difficult question. I mean, it's very difficult to say what one means by true in mathematics, and much less obvious. Is there a source of communication established to express feelings beyond natural matter and the experience of sense perceptions? Well, I would think most of our talk was not about natural matter or sense perceptions. Certainly most of the New York Times is not about either. I must miss the point. Is there a way of communicating about a supernatural experience? I think the experts say not very good. They say it's ineffable. I am not an expert. What is... Oh, we'll skip this one. In fact, we'll have one more.
Yes, sir. There's one more after the others have been asked.
Will you comment on what contribution, if any, Jesus Christ and his gospel may have to you or science? I really wouldn't know about science because this is a matter of history which I am sure is very tangled. It is hard to imagine the history of Europe without Christ, and it's hard to imagine the history of science without Europe. As for myself, I would be the poorer. I don't know whether I'd be a worse or better scientist, but that's not what you wanted to know.
We are deeply indebted to you, Dr. Oppenheimer, for what you have said, for the spirit in which you have said it, and for the great frankness with which you have affirmed that there were realms beyond your particular knowledge, and that
we live in a very unusual world, marked by great and irreversible changes that occur within the span of one man's life. We live in a time where our knowledge and understanding of the world of nature grows wider, broader, and deeper, with unparalleled speed and scope, and where the problems of applying this knowledge to man's needs and man's hopes are very new and only a little illuminated by our past history. In traditional societies, it has always been the great function of culture to keep things rather stable and quiet and unchanging. It has been the function of tradition to assimilate one epoch to another, one episode to another, 1 year to another. It has been the function of culture to bring out meaning precisely by pointing to the constant traits in our life, which in easier days one talked about as the eternal verities, and to let the meaning shine from the fact that some things could be counted on to be there, to be steady, in spite of the great flux with which nature surrounds us. In the most primitive societies, if we believe our anthropologists, the principal function of ritual and religion, of culture as it is practiced, is in fact almost to stop change. It is to provide for the social organism what life provides in such a magic way for living organisms, a kind of homeostasis, an ability to remain intact, to respond very little
to convulsions and alterations in the world around. Now today, culture and tradition have assumed a very different intellectual and social purpose. I will be coming back to this throughout the talk. The principal function of the most vital and living traditions today is precisely to provide the instruments of very rapid change. There are many things which go together to bring about this alteration in our life, but probably the decisive one is science itself. I use that word as broadly as I know, meaning the natural sciences, meaning the historical sciences, meaning all those matters on which we can converse with each other with a certain objectivity. I shan't harp on the distinction between science as an effort to understand the world, to find out about it, on the one hand, and science in its application in technology as an effort to do something we hope useful with the knowledge so acquired. But a certain care is called for if we call this the scientific age. We make this a little too simple. On the one hand, a great deal has come along with the scientific age, culturally, practically, technically, economically, spiritually. These have been concomitants in our history, but are perhaps not inevitable. You see this when you see the rapid growth of science in a country to which it's not indigenous. Japan may be an example. And for another, when we talk about science today, we are likely to have relatively fixed stereotypes. The biologist with his microscope, the physicist with his cyclotron. But almost surely a great deal that is not now subject of successful study in science will later come to be. I think we probably today have under cultivation only a very small part of the terrain which will be natural for the sciences a century from now. I think of the fantastic growth of fundamental biology. I think of the fact that man is a part of nature, and as a part of nature, not uninteresting and very open to study. This is for the future. I stress, in a sense that I will come back to, any subject on which the ambiguity of communication presents no real problems has the characteristic of a science. And the reason for this great change from a slowly moving, almost static world to the world we live in is the cumulative character, the firmness and givenness of what has been learned about nature. It is true that it can be transcended when one gets into a new part of experience of the natural world. What is true on the scale of an inch isn't necessarily true on the scale of hundreds of billions of light years. But what we find remains true and proven and fixed, so that everything that's found is added to what was known before, enriches it, does not have to be done over again. One has an essentially cumulative, irreversible character of learning things, and this is a hallmark of science. There isn't anything irreversible about art. It won't go away, but it's not primarily there as something for others to build upon. It's primarily there for enjoyment, insight, understanding. It is this irreversible character which means that in man's history, the sciences make changes which cannot be wished away and cannot be undone. I'll give two examples, very different ones. There's much talk, has been for 15 years, about getting rid of atomic weapons. I, like all people, have a deep sympathy with that talk. But we mustn't fool ourselves. The world is not going to be the same, no matter what we do with atomic bombs, because the knowledge of how to make them cannot be exorcised. It is there, and all our arrangements for living in a new age must bear in mind its omnipresent virtual presence and the fact that one cannot change that. A different example goes back 5 centuries more. We can never have again the delusions about the centrality and importance of our physical habitat, now that we know something of where the Earth is in the solar system and know that there are hundreds of billions of suns in our galaxy and hundreds of billions of galaxies at least within the reach of the great telescopes of the world. We can never again make the dignity of man's life have anything whatever to do with the special character in space and time and mechanics of the place where we happen to live. These are irreversible changes. So it is that the cumulative character, the irreversibility of the growth of the sciences, give a paradigm, an example of something which is in other respects very much more subject to question, the very idea of human progress. One cannot doubt that in the sciences the only direction of growth is progress. One learns more. One may learn that one's made a mistake, but that is to learn more. This is true of knowledge of fact, of understanding, knowledge of skill. When one implies this example, though, to the human situation and complains that we have made great progress in automation, in space research, and so on, but no comparable moral progress, this involves, to my mind, a total misunderstanding of the analogies between the two kinds of progress. I do not mean that moral progress is impossible, but it is not in any sense automatic. Moral regress is just as possible. We have seen too many examples in our own century. Scientific regress is not really compatible with a continued practice of science. What I want to do in this hour is not at all pretentious. I want to discuss some points on the nature of science and its interrelations with culture. It is my hope that talking of these questions may give a little ground for further discussion. I don't have simplest views. I can't subscribe to the view that science and culture are coextensive, that they are the same thing with different names. And I cannot subscribe at all to the view that science is something useful, but essentially unrelated to culture. I think indeed that we live in a time which has few historical parallels, that there are practical problems, problems of the restructuring of human institutions, of their obsolescence and inadequacy, and problems of the mind and spirit, which, if not more difficult than ever before, are different and are indeed plenty difficult. I'll run over the themes that I'm going to touch on. The first is the question of why the scientific revolution happened where and when it did. The second, the pattern of growth of the sciences. The third, their internal structure. The fourth, the relation of discovery in the sciences to our general ideas in matters which are not closely related, obviously related to the sciences. And the next with the question of freedom and necessity in the sciences, the question of the creative and open character of science, its infinite character, if you want. And the last has to do with what direction these various points suggest for us in trying to bring coherence and order to our cultural life, in doing what it is right and necessary for a group of intellectuals, artists, teachers, scientists, philosophers, statesmen, lawyers to do to help refashion the institutions of this world as they indeed need refashioning if we're even to survive. It is not a simple question to answer why the scientific revolution occurred when it did. I think all serious historians would agree that it started in the late Middle Ages, the early Renaissance. It was very slow. Now, no great culture has been free of curiosity, of reflection, of contemplation. To know the causes of things is something that serious men have always wanted, in a quest that serious societies have always sustained. No great culture has been free of inventive genius. If we think of the culture of Greece or the following Hellenistic period, it is, to me, quite puzzling that the scientific revolution did not occur then. The Greeks discovered something without which science would not be possible, something that is foreign to Chinese culture, foreign to Indian culture. This is the notion of rigor, the idea of proof, the idea of logical necessity, that one thing implies another. Without that, of course, science is essentially impossible, because the trick of science, of the sciences, is to find out mistakes. And unless there is a quasi-rigid structure of implication, then if something turns out unexpected, you have no way of knowing where to look for the mistake. You have no way to correct yourself. But the Greeks discovered this very early and codified it very early in their history. They were a curious people. They were inventive. They didn't experiment on the scale of the University of Colorado, but they experimented very, very brilliantly. And they had, and this is something that is only recently appreciated, a very high degree of technological sophistication. They could make very complicated and subtle machines and instruments, and they did. They didn't write much about this, and we find out about it only by recovering the instruments. They did not make a scientific revolution. Perhaps this was because their communication was not adequate. For us, this is the central point, but it seems very good. They were a small society. They talked freely with one another. The record of these talks is as good reading, even today, as anything that's ever been written. I believe that the answer lies elsewhere. In a matter of history, of course, to assign a cause is not a very rigorous thing, because nothing ever happens twice. I think that the best guess is that the scientific revolution took, in addition to what the Greek intelligence contributed, an element that is also not present in Chinese culture and is wholly absent in all the forms of Indian culture. It took precisely an idea of progress, not the Greek idea of progress in understanding, but of progress which has to do with the human condition. Progress as is well expressed in the second half of the famous Christian dichotomy, faith and works. The notion that the betterment of man's condition and his civility have deep meaning, and that we all have a responsibility and a duty to it, to history and to man. This is, of course, an Old Testament idea, and its rediscovery in the Renaissance and its resonance in the Protestant faiths seems to me a very essential condition for what has happened since. This, and of course the rediscovery of the classic world of Greek science, mathematics, and philosophy. It was all quite slow in the giant days of Kepler and Newton. But by the 17th century, there were enough men involved so that in all the deeply civilized countries of Europe, and then in this country, societies were formed, academies, to bring men together for the promotion of useful knowledge in this country, for the study of nature, the discovery of new knowledge in England, the Academy in France. They could talk to one another and bring to the prosecution of the sciences that indispensable element of working together, of correcting one another's errors and admiring and being grateful for other people's skills that characterize these parts of human life and are their true hallmark. These scientific communities were celebrated in the Enlightenment of the 18th century. And in this we see the first explicit articulation of a harmony between the sciences, the notion of human progress, the spirit of fraternity among men, an unending increase in knowledge. You find it all in the words of Franklin, even more, with a certain superficiality but very great beauty. Just before Newton, Hobbes wrote, "The sciences are small power." And he said the reason was that nobody could understand them except the men who did it. A century later, the encyclopedists were saying just the opposite and basing their hopes for the freedom of man, freedom from tyranny and freedom from superstition, on the progress of science. This context in which the sciences were born has largely accompanied them. Science was born in a context of fraternity and even of a universal brotherhood. It has encouraged a political view, ours, which is egalitarian, permissive, pluralistic, and liberal, everything for which the word democratic is rightly used. And the result is that the scientific world of today is not only a very technical one, and not only one of very rapid growth of knowledge, it's also an awfully large one, an open world, which of course not everybody does everything, in which not everybody is a scientist or a Secretary of State, but in which we fight very hard and rightly against inappropriate arbitrary exclusions of people from any works or discourse or position for which their talents and their interests may suit them. Thus we face our new problems created by the practical consequences of technology and the vast intellectual consequences of science itself in the context of a world of 2 or 3 billion people, in the context of an enormous society, in a context of a society for which none of our institutions were ever really designed. We are facing a world in which growth is characteristic, not just of the sciences themselves, but of the economy, of technology, of the spread of institutions. You can't look at a paper, not one day, not even in Boulder, without knowing all about it. I've spoken of the growth of science, noticing that it started slowly. And as I've said, there are many sciences still to come, hardly born. But from the 13th century to the 20th is a long time, and the growth has been spectacular. One can measure it in a number of ways. I don't mean a growth in quality. The excellence of scientists hasn't gotten any greater. His knowledge, his power does, but not his quality. There isn't anybody better than Newton, or for that matter Kepler, just as there is no playwright better than Sophocles, and no gospel greater than St. Matthew or the Bhagavad Gita. But something has happened, and that can be measured, and that's been done. One can measure how many people work on scientific questions. One can count them. One can notice how much is published. These two criteria show a doubling of scientific knowledge about in every 10 years. I have one friend who calculated that one journal, an American journal for fundamental physics, one of many we publish here, one of dozens that are published throughout the world, that if it continues to grow as rapidly as it has in the last 15 years, next century it'll weigh more than the Earth. It's not only funny. In 15 years, the volume of chemical abstracts has quadrupled. I think that molecular biologists say that in 5 years, more has been learned about the nature of life than in all human history. If you talk about scientists today and mean by that people who devote their lives to the acquisition of new knowledge or to its direct application, about 93% of us are still alive. This enormously rapid growth, which has been sustained not uniformly in the various sciences for about 2 centuries, means, of course, that no man learned today as a boy or a youth more than a small fraction of what he ought to know in his own field. Now, there are a few points to worry about. One is the natural reaction that most of what is published is trivial. It I'm afraid, isn't so. We are, after all, self-serving people, and we wouldn't force ourselves to read through masses of things if there were any way to avoid it. We don't publish things that we can get along without. And the second is a deeper point, and that is that very often new things make it possible to forget some of the old. If you find a general law, you don't need to remember all the instances that were compiled before. And there is truth to that. Any great new understanding, any great element of order that's discovered does, to some extent, clear the slate of past knowledge. But this is opposed by the tendency to explore more widely in newer and more remote fields, remote simply from ordinary human experience, maybe remote in space or time. And one can't, in general, forget too much of the past of a science, because it is not only the means whereby new discoveries are made, it is, in a logical sense, the means by which the meaning of the new discoveries is to be explained and made concrete. It is the tradition of a science which gives us the instruments in terms of which new things are found, both in physical terms and in terms of ideas and in terms even of language. It is the strength of the scientific traditions that they provide this forward thrust. A third point, of course, is that the growth I've described will not, just as a mathematical rule, continue indefinitely, and we think that there will be some kind of saturation in which things don't double every year, but at a point at which the acquisition of new knowledge is very much greater than it is today. Not everybody will be a scientist. There will still be some vice presidents and some lawyers. Here and there a farmer. This raises, I think, a rather serious question. In a quite clear and practical way, a man who is interested in using his mind and learning will have a choice. Obviously, he will try to compromise. On the one hand, if he's a professional, he may continue to learn about his own field in a hard, intimate, detailed way, knowing it as a craftsman. Then the field will not be very wide. His knowledge will be partial, but it'll be intimate and deep. Or he may, on the other hand, say that he will try to learn broadly and therefore probably superficially about what goes on in a wide area of science, in many of the sciences, but then he won't be competent and he won't master it and he won't have this intimacy and depth. The reason I emphasize this is that contrary to the general view, the cultural values of the life of science do not lie in the broad synopsis. They lie precisely in the intimate, workmanlike view. Here are the hard lessons, the real choices, the great disappointments and astonishments and discoveries are clear and detailed, and this is where science is most human and where its analogies with the arts are most deep. The structure of the sciences can't be very simple in this situation. It isn't just that everything is related to everything with a great intimacy. All of the sciences grow out of common sense. They grow from curiosity, observation, reflection, and then the refinement of observation, the refinement of analysis, and by exploring and pushing things a little further than in ordinary life, making them a little more extreme and abstract. And in this novelty, then, there are usually surprises for us. We have to talk differently about what we find. We find opportunities for exploration, as with the telescope, which simply could not be imagined within the framework of a completely non-technical life. The old ways of talking get so cumbersome and inappropriate that we make a big change and one recreates one's whole way of describing this part of nature. And in all of this, we follow the rule that we are prepared to say just what we've done and what we've found, and to be patient and wait for others to look and see whether they find the same things, to reduce to the point where it makes no real difference the normally overpoweringly vital element of ambiguity in the way we talk about things. We all live by being ambiguous, by not settling things because they don't yet have to be settled, by suggesting more than one thing because their co-presence in the mind is a source of beauty and resonance. But in talking about science, one can be ambiguous, of course, but not when one comes to the clinches. Then we must be completely clear and straight and without any doubt that what we say is what the other man understands. He must be schooled to understand it, but that's what we come to school for. And we tell him what we found and how we did it. And if he doesn't understand us, we may visit him and try to help. If he still doesn't understand us, we go back home and see if we made a mistake. And out of this, there comes this firmness and solidity, which is the miracle of the world of the sciences. Well, how does it go? In studying the different parts of nature, one explores with different instruments, and one gets a kind of branching of the tools, of the ideas, and of the words, so that what was our own common sense and our own common talk develops into specialized and different ways of dealing with the different aspects of nature. This tree-like structure, all growing from the common trunk of our common life together, has branches which correspond to different kinds of questions, different kinds of ways of asking nature, different ways of talking about nature. And the unity of science, apart from the fact that it has this common origin in our life together, is not at all a unity that one part of it derives from another, or one part of it implies another, or that one part of it is logically identical with another. That is occasionally, but rarely so. That there is some way of making a correspondence, a unique correspondence between genetics or topology, to take an unlikely example where there is indeed a small connection. The unity of science consists of two things. First, and ever more impressively, an absence of inconsistency. We talk of life in terms of purpose and adaptation and function, and it's hard not to talk so. But you will find in life no tricks played on the laws of physics and chemistry. These laws will not give you very much useful and interesting insight into the great problems of living things, but they will apply. In the past, I should say. In the past, there has been no indication that anything we find in one part of nature is out of harmony with what we find in others. But it may, of course, involve a different set of preoccupations. It must. And the contrast between the kind of questions we ask of a living organism and the kind of questions we ask about a developing galaxy will illustrate this. Very often between two different branches we find a sharp, important mutual relevance. They throw light on each other. Sometimes it's one of the great moments. Things that have happened in different parts of science turn out to be parts of an even greater overarching discovery. But the image that I have is not one of an array of laws and facts, each following from something more deep and fundamental, but rather a living thing, a tree, if you will, but a tree that does have this unlikely habit that the branches touch and then grow apart again. It's a sort of network. The knowledge that is being increased in this extraordinary way is therefore inherently, rightly, very specialized. It is the specialization of science that gives it its thrust. It's different for physicists, astronomers, and the different kinds of biologists, mathematicians. There is this important mutual relevance. But even in physics, where we fight very hard to keep the different parts of our subject from flying apart, we'd like to make it so that physicists can always talk to each other and understand. We don't entirely succeed, in spite of a passion for unity that is very strong. The traditions of the sciences are specialized, and that is their strength, that they use just the words, the machinery, the concepts, the theories, the instruments that fit their subjects. They're not encumbered by having to try to fit other sorts of things. It is the specialized traditions to which we owe it all. And this is, of course, one of the things that makes the very great problem of our time, the problem of teaching, of explaining the sciences. When we get something powerful and general, a great law of nature, then just by virtue of the fact that it's in the logical sense very general and encompasses a vast range of experience, just then, in the words we use and the ideas they represent, it is most specialized and really, without preparation and care, quite unintelligible to anyone but a specialist. The great laws of physics today, they don't describe the whole physical world, or we'd be out of business, but they describe everything that an ordinary man notices about the physical world without fantastically impudent instrumentation. These great laws cannot be formulated in terms that can be reasonably defined without a long period of schooling. It's not quite so true in newer subjects, but comparably. And these specialized communities that know their onions, these guilds if you want, they're a very moving experience for those who participate. There have been many temptations to build something in analogy to them in other human activities. A simple analogy, one that has been talked a great deal, is this. If biologists or astronomers or physicists can work together so effectively across national boundaries in countries with different cultures, different politics, different religions, even in countries with great hostility, is this not a way to bring the world together? It certainly is one of the few things we know how to do. We are doing a little of it. We should certainly do all of it we can to promote international collaboration of the most intimate and direct kind. But it is, of course, a very fragile and limited way to bring the world together. And I will turn a little later to a generalization that may be called for by these times. Another point is that the patterns, the habits of the sciences have to some extent, because the way universities work, also been applied to philosophy, to other branches of learning, to the arts. What one calls technical philosophy, which is philosophy as a craft, philosophy for other philosophers, and art for artists and critics. I think that these are profound misreadings and even subversions of the true functions of philosophy and art, which are not, in my opinion, addressed to specialists, which are should address themselves to the general common human problem, to man, not of course to everybody, but to anybody. It is clear that if there's any truth at all to what I've been saying, we are faced with a formidable problem of communication, of telling people about things, and of teaching. I don't think there's any escaping this. I think that it's a job which will occupy a greater and greater part in human life, an immense job, never ending, never done, teaching on all levels, in every sense of the word. I think also it's one of the noblest of human efforts. It's often been said that great discoveries in science, when they come into the lives of men, affect their attitudes toward man's place in life, man's views, his philosophy. And there is surely some truth in it. We're all taught how it was with Newton and with Darwin. But it's a little tricky. Newton is not a very good example, for when we look closely, we're struck by the fact that in the sense of the Enlightenment, the sense of a coupling of faith in scientific progress and of man's reason with a belief in political progress and the secularization of human life, Newton himself was in no sense at all a Newtonian. His successors were. There are, I think, 2 points. First, if discoveries in science are to have an honest effect on human thought and culture, they have to be understandable. That is likely to be true in the early periods of science, and only in the early periods of science, when it is talking about things which are not too remote from our ordinary experience. Some of the great discoveries in this century go under the name of relativity and uncertainty. And I think when most people hear these words, they think that's how I felt this morning. I was relatively confused and quite uncertain. You really need to go to school to know what these words, tortured out of all relation to the common use of the words, means. What they really mean. I think the reason why Darwin's discovery, or rather perhaps his great and open hypotheses had such a great impact was in part because it was really a very simple thing in terms of ordinary life. We can't talk about what's going on in biology today in ordinary language, but he could. And I think that the great effects of the sciences in stimulating and enriching philosophical life and cultural interest are typically confined to the rather early times in the development of the science. But then there's another requirement. I think that's a necessary one, but not sufficient. I think that discoveries only really resonate and change the thinking caps of men when another condition is satisfied, when the discoveries feed some hope, some need that pre-exists in the society. The real sources of the Enlightenment they were fed, of course, by the scientific events of the time, came really in the rediscovery of the classics, perhaps primarily in the classical political theory and in the Stoa. And I think that the hunger of the 18th century to believe in the power of reason, to throw off authority, to wish for a secular culture, to take an optimistic view of man's condition, these caused men to seize on Newton and his discoveries as an illustration of something already deeply believed quite apart from the law of gravity or the laws of motion. And the hunger with which the 19th century seized on Darwin had very much to do with the increasing awareness of history and change, with a great desire to naturalize man, to put him in the world of nature, which pre-existed long before Darwin and made him welcome. I have seen an example in this century where Niels Bohr, the great Danish physicist, found in the quantum theory, when it was developed 30 years ago, this remarkable trait. It's consistent with describing an atomic system much less completely than we are used to describing large-scale objects. We have a certain choice in which traits of the atomic system we wish to study and measure and which to let go, but we don't have the option of doing all of them. This situation, which we all recognize as familiar in human life, excited in Bohr his old view of the human condition, that there are mutually exclusive ways of using our words, our minds, our spirits, any one of which is open to us, but which cannot be combined. Ways as different, for instance, as preparing to act and entering into an introspective search for the reasons for action. This discovery has not, I think, the discovery in physics, penetrated into our life and our culture. I wish that it had. It is a very good example of something that would be deeply relevant to our attitude toward things if it could only be understood. Einstein once said that a physical theory was not really determined by the facts of nature, but was a free invention of the human mind. This raises the question, how necessary is the content of science? How much is it something that we are free not to find? How much is it something that could be otherwise? This, of course, is rather an essential point in asking how we may use the word objectivity, or even the word truth. Do we, when we find something, invent it or discover it? Well, it's just what you would guess. We are, not individually, but in our tradition and in our practice, and with men of genius also as individuals, free to decide where to look at nature, how to look at nature, what questions to put, with what interests and with what purpose. But we're not the least bit free to settle what we see. Men must certainly be free to invent the idea of mass, as Newton did and as has been worked on by the schoolmen ever since. But having done so, there are some things we're not free to find, that the mass that determines the inertia of a body and that determines its gravitational field are different, or that the light quantum or the neutrino have any mass other than zero. Men were free to discover and invent the idea of an electric charge, but having invented it, we have to notice that all of the more or less elementary particles in nature that we know today have either the charge of the electron or its negative or zero charge, nothing else. So it is, we're free to start things, free to go about them, but then the rock of what the world is really like limits and shapes this freedom. That is why the ontological interpretations of the word objective don't seem very useful, and why we increasingly use it, not ontologically, but to describe the clarity and the lack of ambiguity, and thus the effectiveness of the way we can tell each other about what we have discovered. From all of this, it's fairly clear that in the sciences, total statements that bravely use the word all with no qualifications, are not very likely to occur. In every investigation, in every extension of knowledge, we're involved in action. And in every action, we're involved in choice. And in every choice, we're involved in a kind of loss, the loss of what we didn't do. You find this in the simplest situations. You find it in perception, where the possibility of perceiving is coextensive with ignoring many things that are going on. You find it in speech, where the possibility of understandable speech lies in your paying no attention to the tremendous miscellaneous racket that I'm making and hearing the words. Meaning is always attained at the cost of leaving things out. One finds it in action, and it's of course a recurring theme of the arts and of literature. And one finds it in the idea of complementarity, this trait of atomic physics, where it is formally recognized that the attempt to make one sort of observation forecloses and ruins the attempt to make another. We have freedom of choice, but we have no escape from the fact that when we act, we also fail to act. In practical terms, this means, of course, that our knowledge is finite and never all-encompassing, and there is always much that we necessarily miss at the cost of perceiving and knowing. There is always much that we cannot get hold of because the very act of learning and ordering and finding unity and meaning, the very power to talk about things, means that we leave out a great deal. Now, I don't mean this mystically, but factually and indeed very modestly. There is every reason to take pride in all that's been learned about nature, and a little bit, not much, about ourselves. But there is a good deal of reason to remember that this is always done at the cost of losing information which was there to be had. Ask the question, would another civilization, based on life on another planet not too unlike ours, in its ability to sustain life, would it have the same physics? I have no idea whether it would have the same physics or not. It wouldn't find other answers for the same questions. There wouldn't be any irresolvable contradictions, but they might just be talking about very different subjects. This makes of ours an open world, a world without end. I had a friend in Berkeley, a Sanskritist, who used to say to me, make me uncomfortable, that if science were really any good, it should be much easier today to be an educated man than it had been a generation ago. That's because he thought the world had closed, but it's open. The things that make us choose one set of questions, one branch of inquiry rather than another, are of course embodied in the scientific traditions. In the developed sciences, each man has a limited sense of freedom to shape or alter them, but they are certainly not determined wholly by the findings of science. They are largely of an aesthetic character, and the words we use, simplicity, elegance, beauty, indicate that what we are groping for is not only more knowledge, but knowledge that has order and harmony in it. And of course, like everybody else in this world, we hope for continuity with the past. We want to find new things, but something that's not too new. It's when we fail in this great hope that the really great things happen. I should, of course, say what is obvious, that the fact that something is simple, elegant, beautiful, and only moderately new does not mean that it's true. That's another matter. Now, all these points, the origins of science, scientific age, its growth pattern, its branching reticular structure, its increasing alienation from the common understanding of man and from philosophical questions, its freedom, the character of its objectivity, its openness, are somehow relevant to the relations of science and culture. I'm not here talking about the popular subject of mass culture. In talking of that, I think it's right to be critical, but I believe above all that we should be quite human, not a snob, and rather tolerant and rather loving. This is a new problem, and it's not going to be arranged by the methods of Periclean Athens. I do think that in the problems of the mass culture, and above all of the mass media, it's not primarily a question of the absence of excellence. The worker today in Paris or Tokyo or Denver has within reach probably better music, more good art, more good writing than his predecessors ever had. If there is trouble, it seems rather that the good things are lost in the stream of rather poor things. The noise level is terribly high. Some of the conditions for appreciating excellence aren't present. I don't think we eat very well unless there's a certain hunger, and good cooking involves a certain frugality. And there is something wrong with the mass media along these lines. But that's not what I'm after. Rather, I think loosely of what we may call the intellectual community. Artists, statesmen, many professions, prophets, scientists, artists. It's an open group, not sharply separated, and some people think they're in it and aren't, and some people don't think they're in it and are. And it's a growing group, and it's a growing fraction of all people. And as the world catches up with its desperate problems of poverty and doesn't blow itself up, this will go on all over the world. In it is vested the great duty for enlarging, preserving, and transmitting our knowledge, our skills, our understanding of interrelations, of priorities, commitments, ethical injunctions, meanings, to help men deal with their joys and sorrows, with their finiteness and their beauty. Some of this has to do, as the sciences so largely do, with propositional truth, with propositions which say, if you do so and so, then you will see, which have the kind of objectivity that enables them to be checked and cross-checked until, though it's always wise to be open to doubt, there are really good ways to put an end to doubt. This is the way it is with the sciences. It's not all there is to the sciences because they are human and involve a sense of form and a sense of history. In this intellectual community, there are other kinds of statements, not proposition, which emphasize a theme rather than stating a fact. They may be statements of connectedness or relatedness or importance, or they may be in one way or another statements of commitment, committing oneself, or expressing an agreed commitment of a group or a society. To them, the word certitude, which is a natural ideal for the sciences, is not very sensible. Depth, firmness, universality, maybe other things, but certitude, which is a characteristic of verification, is not the great criterion of much of the work of a philosopher or a painter or a poet. For these things are not, as I have outlined, objective. Yet for any true community, for any society worthy of the name, they must have an element of community, of being common, of being public, of being relevant and meaningful to man, not necessarily to everybody, but to man and not to a collection of specialists. I have been much concerned that in this world of change and scientific growth, we have so largely lost the ability to talk with one another. In the great succession of deep discoveries, we have become removed from one another in our traditions, even a little in language. We have had neither the time, nor the ruggedness, nor the skill to tell one another why we have learned, nor to listen properly, nor to see what there was that would increase and enrich our common culture and understanding. And so it is that the public sector of our lives, what we hold and have in common, has suffered, as have the illumination of the arts and the deepening of justice and virtue, and even the ennobling of power and of the quality of our common discourse. We are much less men for this. Never in man's history have the specialized traditions flourished more than today, and we have our private beauties. But in those high undertakings where man derives strength and insight from public excellence, we are impoverished. We hunger for nobility, the rare words, better the rare acts that harmonize simplicity with truth. In this default, I see some deep connection with the great unresolved public problems: survival, liberty, and fraternity. In this default, I see also the responsibility that our community, the intellectual community, has to history and to our fellows, a responsibility which is a necessary condition for remaking human institutions as they need to be remade today, that there may be peace and that they may bear more fully those ethical commitments without which men cannot properly live as men. This may mean for the intellectual community a very much greater effort than in the past. The community will grow, but I think also that the quality and the excellence of what we do must grow. I think, in fact, that with our growing wealth, and in the end the growing wealth of the world, and the possibility that not all of it will be used to establish committees, there may indeed be some leisure, and that a high commitment on this leisure is that we reknit the discourse and the understanding between the members of the intellectual world. In this, I think we have, probably all of us, to preserve our competence in our own professions, or even parts of professions, to preserve what we know intimately, to preserve our mastery. This is, in fact, our only anchor in honesty. We need also to be open to other and complementary activities, not intimidated by them, not contemptuous of them, as today so many are of the natural sciences and the mathematical sciences. And as a very start, we must learn again, without contempt and with great patience, to talk to one another, and we must learn to hear.
You will feel my power. Yes, I'm master. Yes, master.
Leave that to me. Leave that to me.
Yes! Yes, you master.
Death to the living.
Master.
Leave that to me.
My prince.
As you wish.
Yes, master. As you request.
As you wish.
Feel my power. Yes, master. Come to me. Darkness will come.
As you wish.
Yes, master. Yes, master.
As you wish.
My prince. My prince. Yes, master. Yes, master.
Leave that to me.
Yes, master. My prince, master.
Leave that to me.
My prince.
Leave that to me.
Yes!
Leave that to me.
My power. My prince.
As you wish.
You will feel my power. My prince. You will feel my power, master.
Leave that to me.
line.
My prince. Yes, master. My prince. Yes, master. My prince. Yes, master.
Leave that to me. As you wish.
My prince. Yes, master. Yes, master.
dares? Leave that to me. Who dares? Leave that to me.
Yes! I will avenge myself. Where are you, my love?
Yes, master. Yes, master. Yes, master. My prince.
As you wish.
Yes, master.
Who dares? Leave that to me.
Yes! Yes, I'm innocent. Where are you?
Yes, master. Yes, master.
Who dares that to me? As you wish.
Yes.
As you wish. Death to the living.
Yes. My master.
Darkness will fall. Darkness will fall. Darkness will fall. Darkness will fall.
You will feel my power. My prince, yes. Yes. Pinch myself. Where are you, my lost love? Yes, master. My prince.
Who dares?
Master.
As you wish.
Yes, my prince. Yes, master. Yes, master.
Who dares?
Yes, master. Yes, master. Yes,
Who dares? As you wish.
yes. Yes,
Something far as you wish. As you wish.
Yes. Yes. You will feel my powers. Yes, master. Yes, master.
As you wish.
My prince.
Who dares?
Yes, master. My prince.
Dark is from far. Leave that to me.
Yes.
Yes, as you wish. Leave that to
Yes.
me.
I will avenge myself. Where are you, my love?
Who dares? As you wish.
Yes. I will avenge myself. You feel my power. You will feel my power. Yes, master. You will feel my power. My prince. My prince. Yes, master. My prince.
Leave that to me.
master.
Who dares?
Yes, master.
Darkness will fall.
Yes, master. My prince.
Darkness will fall.
Yes, master.
Darkness will fall. As you wish.
You will feel my power. Yes, master. Yes, master. My prince.
Darkness will fall. As you wish.
I will avenge myself. Where are you, my love?
Leave that to me. As you wish. Death to the living.
You will feel my power. You will feel my power.
Factory. They will suffer. As you wish.
My prince. My prince.
Darkness will fall.
My prince. Yes, master. My prince. My prince.
Who dares?
Yes, master. My prince. Yes, master.
Darkness will fall. Fresh blood at last.
My prince, as you request. My prince. My prince.
Darkness will fall.
My prince. Come to me. Yes.
Darkness
Yes.
darkness profound. As you wish.
Yes. Yes.
As you wish.
My prince.
Darkness will fall.
As you request.
Oh! My gold!
Darkness will fall.
To me. Yes. My prince.
Darkness will fall.
You will feel my prince, as you request. You will feel my power. Yes, my prince master. Yes, master.
this filthy. Leave that to me. They will suffer. You will feel my power. Yes, I listen. Where are you? My prince. Who dares? To me. suffer.
Yes. My prince.
Now you die.
As you wish.
You will feel my power. Yes,
Death to the living.
Yes, yes, master. Yes. Yes, master. As you request. Yes, yes, master, master. Yes, master.
Who dares? As you wish. Darkness will fall. Darkness will fall as you wish. Death to the living. As you wish. Death to me. Death to the living.
Yes, my true master.
Darkness will fall.
Yes,
Darkness will fall.
Yes, master.
Darkness will fall.
Yes, master. Yes, master. My
Darkness will fall.
My prince? Yes, master. My prince?
Darkness will fall. Leave that to me. As you wish. Death to the living. darkness will fall. To me.
Yes, master.
Darkness will fall. As you wish.
Feel my power.
Darkness will fall. Is growing inside me. wish.
Retreating to the royal chamber, the High King Sturmia was at the mercy of the undead hordes. The time for retribution had finally arrived, and the shadow of Mortis darkened the sky as the defunct minions destroyed the High King's personal guard and reached the throne room. The death of Sturmia Thunderhammer was prompt. Slaughtered by undead claws, his lifeless body lay asunder beside his royal throne. In the realm, his death would be but a souvenir of a race defeated by the undead hordes. The vengeance of Mortis was finally complete.